So welcome again, and today we shall discuss about the classification algorithms in machine learning. So I'll walk you through the basic introduction of what are classification algorithms. So the meaning is like these algorithms are used to solve supervised machine learning problems. So supervised machine learning we dealt in the earlier episode was that we are working with labeled data set and the output is known. So to solve such kind of problem, to map this input to the output, we are using classification algorithms. This classifies data into respective classes. Simply, the name suggests that it is classifying. Now, famous example that we've done many a times, I have also discussed it. It is iris dataset, which is a multi-label classification problem. Here you have to classify the data, or you can say the object, output object, into the species of iris, that is Setosa, versicolor, or virginica. So this is what the classification is. And another example is predicting heart disease. Another is detecting tumor, whether it is benign or malignant. And we have done it in machine learning projects. So you can go through that once more if you want to revise it. So this was, we were applying classification algorithms there. So now let's walk you through the classification algorithms. So there are various algorithms which helps you to solve the such supervised machine learning problem, and they are like KNN, that is K nearest neighbor. You've got CART or decision tree. This is the classification and regression tree. It is suitable for both classification and regression problems. Then you've got support vector machines, naive Bayes, and logistic regression. So it is not like that classification algorithms and regression algorithms both are used for supervised machine learning problems. But right now we are dealing only with classification problems or classification algorithms. So now let's move on to the description of each algorithm in short. So like KNN is K nearest neighbor. What happens here is that it uses a distance metric to calculate the nearest distance from the K most similar instances. And what happens here is that this metric, this distance metric could be any, but by default it is Euclidean distance, and it has got a formula also. So this calculates it with the help of this formula. I'm not going into formula calculations, but just to give you a basic brief introduction that this uses this distance metric to calculate the nearest distance of the neighbors. And these K nearest neighbors, or this K is being user defined. I can define it as 1, 3, 5 or 7. Generally it is odd in number, and the new example, whatever the new example we give, the distance is calculated based on the value of the K. Now let me walk you through a little more in depth so that you understand this thing with this figure. Now suppose this question mark is the new example to classify. What happens is that suppose I give K equals to 1. So this new example will be calculated the nearest distance from the class 1 and class 2. The class 1 is the square and class 2 is triangle. So if this new example is nearer to this class 1, then it will be classified as a square. Now if suppose I give K is 3, so that means its nearest distance, the nearest neighbors, that is the triangles, will be the shortest distance from this newly given input. So what happens is that this new input would be classified in class 2. So now this classification is really based on the number of K or the value of K I specify, and based on that the new input will be classified into the respective class. So I can give it 5. So whatever the distance, the minimum distance from these neighbors, the new example would be classified in that class. The simple logic goes behind K nearest neighbor. It is effective, but it is also having its pros and cons, because you have to um, hit and try with various K values in this. So now we move on to our next algorithm, and that is naive Bayes. Naive Bayes works with probability of each class. So what it does, it calculates the probability of each class. It is called naive because this treats every input independently. The negative side is that mm, you cannot treat every input independently. It adds cost of computation, and also that in real life this is not the scenario, because somehow or the other the inputs are related to each other. So naive Bayes is like, it at times gives you good results, but it just depends on, we have to hit and try this, and that is support vector machines. This is also used widely, and this at times gives a real good prediction. This support vector machines, what it does, it draws a line that best separates the two classes. What we want is to classify, so this is separating the two classes. Support vectors, now there's an important term here, support vectors. These are the data points or instances, I can say. They are the closest to the line that best separates the classes. So this will be clear with the help of this figure, that what are support vectors. So you can see this star and this two circles. These are support vectors because they are very near to this support line. And this is what it is doing, support vector machine. This draws a line, this separates these two classes, class 1 and class 2. And these are the support vectors, which just really help you to determine to which class the new instance will belong. Okay. So now we move on to another algorithm, classification algorithm, and that is logistic regression, mostly used. But it is regression and we are using it for classification. So here is a catch. The catch is that logistic regression works well with categorical data, and it is called regression because it uses the equation of line which linear regression uses, right? So it classifies the data into separate classes, and this figure would explain things with very clearly. What happens is, there's a sigmoid function, a slight S curve, and what happens is that if you can see this threshold value, if our data or any instance it lies above this threshold value, then it would be classified in the above class. Otherwise, it will be classified in the lower class. So this is how it works. It just works on this threshold value, and it categorizes, it just classifies the data, the categorical data, which can be really separated into separate classes like 0 or 1, whether I have got these real numbers, or I'm working with a label called survive not survived, whether you are yes or no. So this can fairly work well with these data sets.
Hello friends, and today we'll be discussing about data exploration and data analysis of breast cancer Wisconsin. It is the diagnostic data set of breast cancer, where this is the classification problem. We have to predict whether the cancer is benign or malignant. That is, it can cause cancer, or it will not cause cancer. So malignant is causing cancer, and benign is that it is not dangerous. So how do you get the data? Is that you go to this Kaggle. So I'll show you. What you do is you go on Google, write breast cancer Wisconsin, and hit on this Kaggle link. You'll be directed to this page, and what you do is you hit this download. Okay, and when you will hit this download, it will be downloaded as a zip file. You go show in folder, and what you do is you extract this file. And when you extract this file, it will ask you certain things: the path, destination path. Hit OK, and this is your downloaded file. Okay, data. Now what you do is you just see that this is breast cancer Wisconsin data. Okay, so now we go to home, and this is the Jupyter notebook which I have launched. And how do I launch it? That I just hit Jupyter notebook from the Anaconda command prompt. So you get this Jupyter notebook, and now we have created a folder before. We have done iris analysis tips data set. So data analysis folder is created. What I have done is I have already downloaded the file. So you go to upload, and you upload this file. I think downloads breast cancer and this data. So data.csv, since I already have this file, I will not upload it, but this is how you upload the file. Okay, so now I have created a Python notebook for here. So And how will you create it? You go to new and Python 3. So a new notebook will be created. Therein you can write your breast cancer data or breast cancer prediction. So you can create a new notebook, but since I already have it, I will not use this. So let's start with this notebook. What I have done is I have imported a few libraries. Okay, so what you do is you import libraries, pandas and numpy. This for linear algebra, and this is for your data frame and pandas for better representation of data. Matplotlib and Cbon library are used for plotting, right? What I do is I import warnings, filter warnings, ignore so that warnings do not come. So that is the code for this. Now I have to load this data. So I just load the data. So I load the data. I hit 2 here and shift enter. So this is the heading, second heading. So now when I load the data, what happens is the data is being loaded as pd.read csv data csv, which has been in my working directory. And then what happens is I this is still going on. See, this is, as you can see, the asterisk sign here and waiting sign. So we'll just wait till it's loaded. Okay, it's been loaded. So now df.head, we see the first 5 entries of this, and we see that there are 5 rows here by default and there are 33 columns. Okay, so you can see id, diagnosis, radius mean, texture mean, perimeter mean, area mean, and so on. So we can see the worst also, and we have this last column of unnamed 32, and we see all these entries, right? Okay, what next? We go and hit the df.tail and we get the last 5 columns. Okay, so you can see this diagnosis has only M and B. Now let's see whether is there anything else in diagnosis. And first check the shape of the data. My shape of the data is 569 rows and 33 columns. Okay, so now let's see this describe some statistical information, and T is for transpose. That means suppose this count mean will come here. I have created this in the heading. So I get all these 33 this thing here, and this is the value. So we count all our 569 rows, and this mean is, as you can see, that we are getting this mean, which is that means we will be requiring some kind of standardization to get suitable data. Okay, and we can see the standard deviation also is something like this, and then is minimum maximum value 25%, 50%, and 75%. This is what this describe tells us. Okay, let's explore further. So now I want to see how many unique values are there. So df.diagnosis.unique, that is the code we write, and we find that there are only 2 values in diagnosis, that is M and B, malignant and benign. Now DF diagnosis, I want the value count of it, how many are there. So benign are 357 and malignant are 212. Let's have a plot for this. So if I want to show you how does it look like, it looks like this, and this is an object. Okay, this is not numeric, this is M and this thing, but this is giving me a count. So benign, malignant, you can see this is 212 and benign is 357. Okay, let's hit further. Now what we do is we clean and prepare the data for further training of the algorithm, so that this can be fitted in algorithm. Now my algorithm will let's see which I have dropped this ID because ID is not needed in my data. Okay, so if I just show you df.head, okay, that is already yes. So This ID is not needed because I don't have to do anything for that. And also this unnamed 32 which we have seen here, this is also not needed. Okay, so what I do is I will drop these two columns. Okay, so I just drop these two columns. This is what I write, and then I check the head. Okay, so I check the head as, and I see that there's 31 columns. That means these two are dropped. Now what else? Let's see what else we can do with this data. Now since I have to train an algorithm, and an algorithm will not understand this M and B, so now I have to change this into numeric. Either I can perform label encoding, or I can map it, or I can also use an if or else loop. Okay, so I use this diagnosis, and I use this dot map malignant as 1 and benign as 0, and then I tell it to show me this that has been converted. So see, you can see this, that this has been converted, malignant as 1 and benign as 0. So if you have got a dangerous tumor, it will be treated as 1, and if it is non-dangerous, it is 0. Now what if I want to see how many null values are there? So this is how I see it. df dot is null dot sum, and this will give me that, see, all are 0. That means there is no null value here, so we don't have to replace the values. Okay, easy task. This is a code for if you want to apply if and else. Okay, now we see the correlation. This is important because we have to determine whether is there any relation between the two variables or not. So we see this df.corr. Since this um, correlation, if you want to see and examine here, you can just see that radius and diagnosis have high mean, have high correlation. Similarly, perimeter and this has relation 74.74, and area mean is 0.70. Similarly, you can see this concave point mean is also highly correlated. Okay, and you also see that radius mean with perimeter mean has high correlation, 0.99. Also see that the texture mean, okay, perimeter and radius again, see the same, 0.99. Area mean and radius mean 98. Area mean, perimeter mean 98. So we can just see that the area, radius and perimeter, they have high correlation. Okay, similarly we can observe it here also, that compactness, concavity, have they got any high relation? So this 83 compactness mean, if we map it here, concave point mean, so they are also highly correlated. Okay, now let's plot it and see how does it show. So I have also plotted this thing, that plt.hist, that is histogram, and I want to see this mn0. This is also after converting it to 1 and 0. Also you can plot it. So plot title is this diagnosis, M is 1, B is 0, and this is what it shows again, the number of tumors of cancerous and non-cancerous cells. So now we go to, okay, this is the correlation diagram for which we have plotted earlier, of which we have seen earlier. So I set the figure size as 2020, and then heatmap provides this, SNS provides this resource, this facility. So I do the correlation mapping here, and NO true means it will write these numbers inside. Okay, so again we can see here, let's see that the diagonal radius mean and the diagnosis are positively related. Radius mean and perimeter mean again are 9999 highly related. So we can see here the relation, correlation, high correlation. Now what I do is, since I want to first see the mean columns, and as you have seen that there are mean 1 2 3 4 5 6 7 8 9 10. Okay, mean, and this is standard error. So we've got certain standard errors like 10 or so, worst also. So we are plotting it for scatter plot for mean columns. What we do is I assign a column, in that an array I will assign all these: diagnosis, radius mean, texture mean, perimeter mean, area mean, smoothness, compactness, concavity, concave points, symmetry, and fractal dimension mean. Okay, and what I do is I plot an pair plot for this to see the correlation among these three, among these all. Okay, and what I do is data is df, and you go to these columns. Hue is diagnosis, that means 0 and 1 it will be plotted, and palette I have taken as rocket. Okay, you can take any. So now you see this has been plotted, and so let's just see this. Now you see, focus on this figure. This is highly linear. These all. Now what does this show? This is perimeter mean, okay. And what is this area mean, okay? This is radius mean. This is area mean, perimeter mean, radius mean. What can we derive from here? That these are highly correlated. Radius mean, and when you go up and you see that this is radius mean and perimeter mean. Okay, so that means there is a problem of multicollinearity here, and there's perfect linear relation between radius, parameter, and area attributes. This means that there's a presence of multicollinearity. Now what does this multicollinearity mean? That these features are very highly correlated and they're dependent on each other, and this will affect the performance of the model if we will include these in our data set, okay, in our further data. So what we have to do is we have to take only one among these three. So we will select one. Next we see multicollinearity, and another thing, that is, see, the concaveness, the concavity, concave points, and the compactness means they also show some kind of multilinearity, collinearity. Okay, so I am making this hypothesis. Now I have to check whether it is true or not. Let's see. And if you want to see the label, check the label. So here's the diagnosis. This purple color is 0, that is benign, and 1 is malignant. Okay, this pink one is malignant. So let's see now. Now multicollinearity, I have described that this is means that they are highly linearly related, and this also undermines the significance of independent variables. The other variables would be undermined, and the model will not give them preference. So what I use it, how do I remove this? I remove it by using the partial least square regression, or I can use the principal component analysis, which reduces the number of parameters. And regression methods, they will cut down these numbers of parameters or predictors. Okay, now what I do is I have to visualize the correlation matrix to understand this thing. So what I do is, this is the code which has been given in the SNS Seaborn documentation also. So this is from where I have taken it. So correlation is df.corr, and this is how we write it. Mask for the upper triangle, since I want this upper triangle, and for lower, if I want a lower, I'll just write L here. Okay, so mask is equals to np.0. I'm using numpy here, and I'm using triangle upper indices from mask is true. So what I'm doing is I am creating this triangle, this kind of a matrix by this code. Then what I do is I set the figure size as 2020, and the custom color map I give it as CMap. This is what the map, how it looks like. And then I draw the CMap and giving parameters, passing the parameters inside. Okay, and the layout is tight layout. Okay, so this is what it will generate. And as you can see that here also I am getting the same thing. I am getting perimeter mean, area mean, and see, area mean related to radius mean 0.99, again related to, now you see here 0.82 concave points, and for the highly correlated. So this is what it looks like. Okay, so we can verify here the presence of multicollinearity. And now this is the description that radius mean has a correlation of 1 and 0.99, and perimeter mean and area mean columns. Okay, now this shows that there's high multicollinearity, and we have to pick just one. So we can pick radius. Okay, because it is a cell, so it will have radius, and so linking in that, yes, radius is something important, so we can pick radius from this. Now another place is that where is mean and worst column. Now you see one point that radius mean has high correlation with radius worst column. So let's just find out this thing. It is 0.97. Radius mean has high correlation with radius worst column. So just track it. Radius worst 0.97. See, radius mean and radius worst. So that means that the worst radius has got high mean. So we can see that these means are related to the worst column, right? So what I can do is I can drop this worst column because they all are just redundant of the mean values. So, and we also find multicollinearity between compactness, concavity, and concave points. So we can just take one, and I will take compactness here. Now what you do is you drop all the worst columns so that we are left with only few parameters for our algorithm, and we can predict the data accurately. So we take only mean here. So what I do is I drop this worst column, all the worst parts here. So what I do is I drop it, x is equals to 1 again. Then what I do is I then drop all the columns related to perimeter and area also to remove multicollinearity. I will remove them: perimeter mean, perimeter SE, area mean, and area standard error. Okay. Next I will drop it. This is how I drop it. Then lastly we will drop all the columns related to concavity and concave points attributes also. So this is how I will remove it. And then what I do is I verify what does my DF column look like, and this looks like this. So we've got these one: diagnosis, radius, mean, texture, mean, all mean, and smoothness, compactness, symmetry, SE. This is what we are left with. Okay. So now what I do is now I draw a heat map again to see whether is there any high correlation. So again I use the same code here. I just copy pasted it, and what we see here is that now there is no high correlation. You can just see that's only 0.73, and see, there is no high correlation. So we have removed the multicollinearity. Okay, right? Okay. Now what you do is, now the next point is building the model. Now for building the model, we have to first separate the x and y. In x, we've got all the columns except the target one, and in y, we will get this target. So this is how we drop diagnosis, and in y, we have this diagnosis. And then what will I do? I will perform this train test split. I will split this set, and from sklearn, I will import train test splitter. Then I will divide my dataset into xtrain, xtest, ytrain, and ytest. I will perform test size. I give 0.3, which is the standard size. You can give any, and random state is 40. Okay, anything you can give. Then we will do some feature scaling. Now this scaling is done to bring all the values into some standard this thing. Should I get all the values to the same magnitude? That's why I'm using this scaling. So I'm using standard scaler here, and I'm fitting my xtrain and xtest on it. So this is the code for this. I fit transform this xtrain and xtest. So once you build this test size, what happens is your data gets split into xtest. So training data is your 70% and testing data is 30%. Next, let's come to model building and finding out the best one. So we will fit it in various models, and we'll see how each model performs. So now first is the logistic regression. So for logistic regression, we've got this is again a classification algorithm, and from sklearn we will import this logistic regression. I have created one object LR for this. Then in model, fit this model and what we will fit in this xtrain and ytrain. Okay, I'll make the predictions, and for predictions in this object I will again predict this x test. I'm predicting the x test. Now From sklearn, I will import a matrix, that is confusion matrix, and this is for classification problems, as you've seen in the previous video, the theory part of it. Now the confusion matrix, I will plot off the x y test and the prediction one, that means on x test, so that I can compare as if how many are true and how many are false and how my algorithm is performing. So now you look at this matrix, it is 110 and this is true positive. Okay, that means my algorithm is predicting 110 cases rightly. Okay, correctly identify cases. This 5 is false positive, that means these are the incorrectly identified cases. 5 cases are incorrectly identified. 2 is false negative, and this is false negative, that means this is incorrectly rejected. 2 cases are incorrectly rejected and 54 cases are correctly rejected by my algorithm. And if you want to draw this confusion matrix, this is how you draw it, and you can save it also. So this is the confusion matrix: true positive, true negative, false positive, false negative. Okay, now I will go to accuracy. How do you find the accuracy of this? It is the total positive divided by all the instances. So we've got 110. This is 110 plus 54 gives you 164 divided by 110 plus 5 plus 2 plus 54, which is 171. So 164 divided by 171 will give me 0.959. This is the accuracy of logistic regression algorithm which is giving me. Now what I do is I import this accuracy score and I will predict it on y test, because this is a testing data. Let's see how it performs on the unknown data. So this is again giving me 95%, the same accuracy, that is it is performing well enough. Let's see what happens with the decision tree model. Decision tree model, again I do the same thing. From sklearn, I have this tree package wherein I am importing the decision tree classifier. After this, what I do is I create an object for this classifier, I build model, I fit my x train and y train, and I predict this model on x test. Then I build the confusion matrix on the y test and prediction. Okay, and this is what I'm getting. So it is just classifying 105 predictions, previously was 110, so definitely the accuracy would come down, and as you can see here the accuracy is only 90%. So decision tree is not so good model for this. Let's see random forest. Again from ensemble I will import random forest classifier. I'll build an object for this, RFC. For model 3 I have fitted this model on X train and Y train. I will predict this model on X test, and then I will print the confusion matrix for Y test and predictions. Okay, here there are 108 cases which are correctly classified or correctly identified by my algorithm, and 51 are being correctly rejected. Okay, so for this the accuracy is greater than the decision tree, which is 92%. Okay, now what you do is you also print the classification report for this. So classification report, I will print it for this y test and prediction 2. Similarly, you can do it for other predictions also, which we will see now. For this I get the precision as 96, that means they are correctly identified cases. Precision it gives me, and the recall, this is called true positive rate, which means that this is giving me what? This is giving me mixed positive predictions. This is because this is recall is true positive upon true positive plus false negative. That means it is giving me the idea about my algorithm, how is it performing, how well is it classifying the positive instances and negative instances. Okay, and is it correctly rejecting the data also. And precision is just telling me about the positive predictions, how many positive predictions it has made, irrespective of the rejection, whether it had to be rejected or it had to be accepted. So just all the positive predictions about my algorithm it is giving me. But here it is also giving me that the rightly rejected cases by my algorithm also. Okay, what it rightly rejects and rightly accepts. So recall is very important in healthcare sector. Okay, so this is just 0.94 recall. I would like to see higher recall in here. So For benign, I have 0.94, and for malignant, I have got 0.91. That means for 0.91 cases are correctly identified, rejected, so I get the true positive rate from this figure. And F1 score is the harmonic mean of precision and recall, right? So now I can also print the classification report of the above two predictions of logistic regression and decision tree. So here you can see this is 0.96 for both. It is greater for logistic regression anyways, and for decision tree it is less. Okay, right. So now let's come to another way of it's a short way of building a model in a form of an array. So we'll see KNN, support vector machine, and naive Bayes in this. So what I do is from sklearn I will import all the classifiers: k-neighbor classifier, support vector classifier, and Gaussian NV. What I do is I create model list, and in this I will append these. I'll make an object for this, and I will create a this classifier. Okay, so the same way that I was doing above, I was creating an object for this, and the same I'm just appending it in the model. Okay, so this is how I write it. Now from sklearn I will import kfold, and I will also import crossval score kfold CV. Now what is this kfold CV? This is kfold is a resampling technique, and this evaluates the machine learning algorithm. Okay, what it does, it just divides your data set into training into k parts, whatever I have given this here as n splits, that is 10, and the number of split, each split is called a fold, so there are 10 folds here, k fold is 10. It divides your data set into k parts, right? And crossval is like it reshuffles your data. And for more details, please refer to the theory part of the video. Now resampling video I have made, please refer to that. Then what you do is in I create two arrays, okay, results and names, and in that there's an empty array. For that I create this name and model in models, so what the iteration will go on. Now see, k fold I'm giving classifying it as, or I'm giving k as 10, and random state I take as 40. In CV results I will take crossval score, and scoring I have taken accuracy, you can take other also. CV is k fold, that means it will go fit 10 folds, and random state will be 40. What in my model, and X train and Y train. So this model, it will go for each of the models, and it will perform this train test split, it will perform the accuracy, and it will append the result and give me. So in the messages I'm typing that name, CV, result, mean, and standard deviation. So for KNN it is 0.90, for naive Bayes it's 90, and for SVM is 92. Now see, among these SVM is performing the best, and standard deviation seem to be low of naive Bayes. Let's go and make prediction on SVM. Okay, so for SVM I have taken this SVC classifier. I'm making prediction on my test data set. Okay, so what happened here is svc.fit. Again, I'm fitting this thing on my X train and Y train. I will make prediction on X test, and then I will print the accuracy on my Y test and predictions. Classification report is also I'm going to print on my Y test and the predictions, and confusion matrix of Y test and predictions. So see, the accuracy is 96%, highest among up till now we received, and the precision is high, 97% of benign, and 95% of the malignant tumor. And precision true cases, whether it is precision in healthcare sector is not that much valued as compared to recall, because I also want to know the number of cases rightly rejected. So this gives you more robust data. And here you can see the confusion matrix 112, which is higher than logistic regression. Also it was 110. This is 112 cases. This is 53 correctly identified, that's why recall is high. And this is 3 here and 3 here, that means this is 3 are false positive, correct, incorrectly identified, incorrectly rejected, and this is correctly identified, and these are 53 are correctly rejected. So we see that we are getting the best accuracy this support vector machine, which is 96.4%, and up till now. So we can go ahead with different models, different accuracy, and we can boost this performance with the various ADA boost or extra tree classifier. Hi everyone, this video is very important because this forms the basic concept building of machine learning and as where and when to apply the machine learning algorithms. So the questions like how to determine which algorithm is suitable to train our machine, where that is given a data set, which algorithm will be suitable, which algorithm will give us the best result. So this video will address these questions. Once we are given the data, we have a view of this data, and depending on the data we apply the algorithms. So based on the problem categories in our data we apply the algorithms. That is, it all depends upon our data. Now in case of supervised data where the output is known, we have got the data either continuous or discrete. Now, the discrete data is also known as categorical data. This categorical data is in the form of either 0 or 1, true or false, or yes or no. That means you can categorize things and you can easily come up to a conclusion. So, the algorithm for these are support vector machines, naive Bayes, which we shall discuss later on. Now, for continuous data wherein we do not have the the classification or we cannot categorize them, the data is in continuous form. For example, when you predict the house prices, stock market, share predictions, weather forecasting, algorithm do we use for such data? We use linear regression here. Now, random forest is one of the most popular machine learning algorithms which is being used for both the data. It can be used for categorical data as well and continuous data also. Now coming to unsupervised data where the output is not known. Which algorithm do we use here? Now, here we have to keep in mind that the data needs to be grouped or clustered. Hence, we will use the clustering algorithms. The clustering algorithms are k-means, k-median or k-medoid, hierarchical clustering, etc. Now, in case of semi-supervised machine learning, we've seen that reinforcement machine learning is an example of it. So, which algorithm we are using in it? We are using brute force, approximate dynamic programming, Markov decision process. You can see this in the figure, this machine learning and the types of machine learning. We first take unsupervised learning. Here, depending upon our data, we will apply either the clustering algorithms or dimensionality reduction algorithms. Now, where can we use these clustering algorithms? What models can be designed with the help of clustering algorithms? They are recommender system, targeted marketing, customer segmentation, and many more. Now, coming to dimensionality reduction, this is basically used in big data visualization, compressing an image. You want to find out features of an image. An example of this is like Facebook uses tagging of the image. It can determine the names of your friends, it can understand, recognize the faces. So this is machine learning. Next, let's move on to supervised learning. Here we have two important algorithms, classification and regression. In classification, we classify the data either as true or false, 0 or 1, or in separate groups. Now the real life application for these models are customer retention, whether the customer will stick or will fly away. In diagnostics, for example, whether one has got malignant tumor. Then the next is identity fraud detection, wherein whether there is a fraud or there is not a fraud. So with classification algorithm, we can determine these things. Image classification, whether the image is of a dog or a cat or a mouse. So we can use classification algorithms to find out the solutions of our day-to-day problems. The next in supervised learning we see is regression. Now, regression is for continuous data. Here, weather forecasting, market forecasting, expecting life expectancy, stock markets, all fall under regression analysis. That means we have to apply regression algorithms to find out suitable solutions to these problems. Next we see is reinforcement learning. So the real life applications of reinforcement learning algorithms are robot navigation, real-time decisions, skill acquisition, learning tasks, game AI. So one of the famous example is Google self-driving car. So this is an example of learning by doing, rewards and punishments, improving through experiences, and this just evolves over time. So I hope that where, when we apply the machine learning algorithms and where we use regression algorithms, where we use clustering algorithms, and where we use reinforcement learning. So that's all for this video. In the next
Project. Hi, and today we shall do a project on adult UCI dataset analysis with Python. And this adult dataset is available on UCI. So this is the website. This is my website. So you can, I just will give you a basic introduction about what this adult dataset is all about. Now this is about the income. You have to predict whether a person makes over 50,000 a year or not. And this is a supervised machine learning problem. And this is a binary classification problem because you have to predict whether it is over 50,000 or less than or equal to 50,000. And there are various features which we shall explore in the dataset, which we are going to do now. And the links have been provided. I will also provide in the description box. So you can either go through this archives of UCI or through Kaggle. Okay. So now I just come to my Jupyter notebook. See, what happens here is that you have to be in the same working directory. And since I have this folder of data analysis, I'm in that directory. And here I will upload. I have already uploaded the data set. So I have this data set called adult.csv. You upload this here, rename it if you want, or let it be the same. So what I do is I just go back and I create a new Python 3 notebook wherein we shall start exploring this data set and understand its various things. So I just write here adult UCI dataset analysis. Okay. So I just rename this, and now we shall start with loading the basic libraries. This is how we start with the project. So we load the basic libraries, and just click on this. When this turns blue, you just hit 2. That means the second heading. So now I come to, like, you can import pandas as PD and import numpy as np. For data visualization, we will import matplotlib.pyplot as plot, and I will import seaborn as sns. I will also import plotly. So we'll just mix all these visualization together and see what it comes out to be as px, and hit shift and enter. Run this, and in the meantime I will import warnings, just because it will not give me much warnings, because this is how you write import warnings. Warnings.filter warnings. You filter these warnings and just write here ignore. I will ignore these warnings. Okay, shift enter. Now we will go to load the data set. So we will load the data. Okay, and how do you load this data? With the help of pandas. So df is equals to, I will go and tell pandas to read the CSV file, and my CSV file was adult.csv, right? Okay, and then I will tell it to read the first 10 entries so that I can see how does this loaded. Okay, now you can see this data set as you've got age, work class, something called weight, and education, number, marital status, income, and this is the income. This is the last feature. So the output has already been included. Okay, so this makes it supervised machine learning, And as you can see, this has got binary, this thing, less than equal to 50,000, and this is more than 50,000. Okay, so we've got race, relationship, gender. According to these features, we have to predict whether this person makes over 50,000 or not a year. So okay, I will tell you one more thing, but first let us just see the shape of my data set. So we'll see the shape, and we see that there are like 48,842 rows and 15 columns. Okay, fair enough. And another thing is that I want to show you something. Okay, let's check the data types, df.d types. In this we can just see the data types, and we find that this is a mix of integer and object, that is categorical and numeric variable. And this work class, marital status, occupation, all these are in categorical format. And rest, you can see that education is again object, and this hours per week, and capital gain, capital loss, this FLN weight. This is I'll tell you what this is. This is something called written it here. What is this? This is the final weight. It is in continuous format. These are the CPS files. They are controlled to independent estimates of the civilians and blah blah blah. So now we come to this. This is also an integer format. What I'm more concerned is about that you understand that which of the features are in integer format and which are the categorical features, so that we can deal with them before feeding it to the algorithm or training the model. And now after doing this thing, I want you, let's just explore one more thing, and that is whether this is null dot sum. That means how many, I want to find out the total number of zero or null entries. Now this is showing me that there are no null values in either of the features, but I'll tell you one thing, there are no null values, but if you have observed here, we've got certain question marks. You see this entry 4, and you see this question mark here in work class. You see this in occupation, question mark. You see this work class here, again a question mark. 6th entry, here a question mark, and so on. So there are many question marks. Now we have to figure out how many question marks are there. Is it really, can we drop these? And we have to deal with these question marks. This is corrupt data. So either we drop it or we fill it with something. And we also have to determine in how many columns do we have these question marks. So just study this data, this table, that this work class has this question mark. All right. This occupation has these question mark. And we have also found out that one more column has, okay, we'll just explore it. Okay, let's explore this. So what we do is, now I'll just add a few columns for a few rows. Okay, now let's I'll also show you one thing more, that is df.n unique. And what does this unique does, it gives you the unique values of all the features. So in age, we've got certain like something like 74 different unique values, and we shall see that this age group lies between what to what. Work class is 9. Okay, it has got 9 unique values. Now you see this FNL weight is like 28,000 something. Education has got 16 values. Marital status has got 7 unique values. My god. And then you see this race, gender, and everything. So this is how it is. And income has got, thank god, it has got just 2. It's binary. Okay, so income more than or equal to 50 or less than 50,000. Now you come to some statistical calculation, and we do this df.describe. And in this describe, what I'll do is I'll take this transpose of it. So in transpose, what happens is the rows are converted into columns. Suppose if I don't give this, this will be like this. And if I give dot transpose, it will be rows converted into columns. So you can see this age, you can see the count of this, the same number of rows, and the mean of age is 38.6, and the minimum age is 17 years, and the maximum age is 90 years. So our data set is spread in the age group of 17 to 90 years. You can see the education number. It is like something, minimum is 1 and maximum is 16. That means the number we are talking about, and it is almost redundant information like of education. Capital gain and capital loss again can be seen here, and hours per week. So we've got maximum hours per week is 99 and minimum is 1. Okay, All right, now let's start with something. Now we'll come to this question mark, this thing, how to deal with this. So I will walk you through the value count function, which is really good. It comes handy, and its utility I have given it in this website. Just go and check it out. So what we do is we will start with the df, since I want to find out how many features and their counts, how many counts are there for each feature. So I will take first the work class, since I have this, and I will find the value count for this value. This is how you write value counts, and you see this. Okay, so in this work class column we have got all these values. Can you see these values? Okay, so this is like the private, and in private we have got something like 33,906 values, and you see here question mark. So in this work class I have question mark, which has got certain like 2,799 values. This is quite a large chunk, so I dropped the idea of dropping these columns, these rows, because it will really affect the quality of my data, the prediction, because I am already eliminating so many values, right? So I will not drop it. Let's see what we do. So this private, we have found out that in work class we have got certain like question mark values more than 2000. Let's explore another feature, and I will take you to, like, we have seen it in countries. Okay, so I just if you want to check out the columns and you don't want to go above, just write here columns. Okay, columns it is. So you have seen this work class we have done. Now the next was an occupation. Let's check this occupation. So what I do is I just copy it and I will write it here, and here in work class, rather than here, I will write here occupation. And okay, let's see. So in occupation you've got so many occupations, and we have seen that the unique value for occupation was something around where is occupation, 15 unique values. And here we see that we have again got this question mark and some like more than 2000 values are here for occupation again, like in question mark. So you don't know the occupation of a person, and it has been marked as question mark. So this question mark is a filled value, it is not null, and my data reading is like there are no null values, but I have to fill this to get a right prediction. So, and we see one more thing here, that this professor's specialty has the highest number of occurrences. So 6,172, and I see here that private has the highest number of occurrences. So the value which has got the highest number of occurrences is called mode. So what I can do is I deal with this question mark. Either I fill this with mode, right, or I fill it with some another value. I create some another feature. So I don't know some another feature. What I do is I will just replace it with mode. Okay, let's just figure out a few more question marks if I have it in different features. So now what I do is I will check it in, I have checked it in occupation. Now let's check it in something else, and I think that is native country. I have this is a native country, and native country. So native country dot value counts, if you will give it, it will come out to be yeah. So this is quite a long length. Okay, and but you have to figure it out that where is it. So you can see this question mark here, and it is 857 values. So this question mark, this is really having a lot of values here. So similarly you can find it out for different columns, and this is your homework, guys, please do it. But I'll just go through a few more columns, a few more exploration, so that it becomes a little more clear. Let's just check for marital status. Okay, marital. And let's see how many values does this have. Dot value counts. And we find, okay, so this is like different marital status. You have got married, and you have spouse, never married. So divorced, separated, widowed, married, spouse, absent, married, AF, spouse. Okay, thank God you've just got 7. Or so they could have also included married, spouse, occasionally present, occasionally absent. So okay, jokes apart, we just move on to something different. Now let's just check the gender. I think gender, we have the 2 values only, and so gender dot value counts, I would just come. Okay, so males are more as compared to females here in the data set. And you can similarly check for relationship, and I have checked it. And now let's just check this race. Okay, so if I go to this race and dot value counts, let's see how many race they have included here. This is a good practice. You can just exercise this thing. So it's white, black, Asian American, and etc. And others are also there. So this is the race here. One important thing which I want to show you is that df dot income, which is a target variable here, let's just check its value count, how many values are there and what it is telling us. So it's like less than equal to 50,000, it is 37,000, more than 37,000. And if it is greater than 50,000, then it is 11,687 entries which we have. And we have to correctly map it so that we train this model. Okay. Another thing which I want to show you here is something linked with the data part. I will just call here SNS. I will invoke SNS dot count plot to plot this and show you. I will just copy this, and I could have also used it here in fact. And let's take the palette equals to, okay, I'll take here cool, warm, and let's make it a little interesting with adding hue, and I will add hue as gender. And from where it will take this will take it from data, and this data is df, and so that it does not include any comments, I will include the semicolon. So now you see this. Okay, so you can see this gender, male and female, and the males having income less than equal to 50,000, as you can see the count here, it is greater than 20,000, and the females it is like around 15,000, and the males and females with the respective count for greater than 50,000 is here. Okay, all right, so you can just change the hue and experiment with things like you can change your race and see like how many people are getting what kind of income, and according to their race, according to their gender, according to, you can use different occupation will be much bigger. You can just write here marital status, and you can write here, right? Okay, relationship, let's take relationship. I think it is relationship only, ship, yeah. Okay, so this is like this is what we see as per this data set, that you see this northern family and husband or child, they are forming the majority part of having income less than equal to 50,000, whereas those who are having husband are having this greater than equal to 50,000. So there are many things which can be inferred from this, So I leave this analysis unto you and to how to figure these things out. Next, we come to a little more detail. Now we'll come to fixing of this data exploration part we'll take further, but first let's just I would fill the question mark. Okay, filling question mark values. Let's just deal with this first. And how do I fill this? I will replace it with mode. Okay, I will replace the values with mode, right? And I'll convert this into hash comment so that it does not throw an error. Now what I do is I would just simply write here the columns which were having this question mark. So this was like workplace, that was work class that was having. And how do I write it? So in this work class, okay, you go to this work class. I'm telling it to go to the work class, and what you do there, you replace what you should replace this question mark with what? Replace this question mark Okay, what is it? With private. Okay, that is the mode. And next I come to the occupation. So I write here occupation, and what I do again is I again write here occupation dot replace the value, the function which I wanted to perform, and I write here question mark and replace it with, that was if you remember guys, that was professor specialty. Okay, next again we had it in one more column, and that was native country. And here I will write df, what is it, native country, dot replace the question mark again, and this replace this question mark with what, with the most frequently occurring. If I want to show you this, we've done it here. I think it is US. Yeah, that's US, because the native country here, you can see the US has got the highest value here, right? Okay, so we will replace it with United States. Just write it here, United States. United States. Okay, so I will just replace it, and I am about to do this. Okay, so okay, spelling problem. Okay, replace. So this is done. Now let's just check it. df.head, has it really been successful? I check the first 8 entries and I see that yes, this has been replaced. You can see here this has been replaced by private, and in this only there was a question mark which was professor specialty, and in the 6th entry also we had this problem. So this has been replaced. Now we move on to another thing which I want you to do is like since you see this data set, there is a lot of data. In relationship you have got some like 7-8 features. In race you've got features. In occupation you've got like 7 occupations. Marital status is 7, occupation is 16. So why not change it to something useful, something crux brief, so that we can easily infer this thing. So what we do is we just play around with a little column. So we'll do some feature engineering here, right? I will just do something called feature engineering, wherein I will first deal with the education categories. Okay, so education category will be dealt with now. So there are education categories. If I want to show you the value count of education, and this has certain values like value count. Okay, I have not done it for education. I will do it for education. So if I just do it df dot there are certain values in education which you should see, and they are like need to be dealt with. So you can see there are like so many values, and you've got it here like redundant, so many information, like you're in 11th, 10th, 7th to 8th, 9th, 12th, what is this, preschool, 1st, 4th, 5th, 6th. So we'll deal this with schooling. Either we can replace all this till 12th in school, this associate, academic, bachelor's, master's into just one category, some college. We can just reduce it with in few data, right, instead of having so many features. So let's do this. Okay, so we'll do this here, and we have to write it for every this thing. So here what I do is, just bear with me because this is quite long, and we write it here df.education is equals to, what you do is df.education and dot replace. Guys, you have to practice with me. Just I'm writing it because we can do it together, and just fill it with these values. So I will take these values. and I will take this replace the preschool. I will replace preschool. I will replace first till fourth. Then there was, okay, this is first. There was fifth, okay, fifth till sixth. All redundant information. I don't want all this. And there was seventh till, say, eighth. Then there was ninth. So you have to write all these columns. You have to mention here 10th. Okay, there was 10th also. So just keep writing, keep practicing. 10th. Then there was 11th, 12th. Okay, so I have still to go 11th and okay, in column that is 12th. So this is string. And now what value I want to pass, I will write simply here school. Okay. All right. Next we come to df.education, because in education only you've got so many values here. And I write here df dot again education dot replace the same function spelling, and I will write here what I want now. So you've got something called high school graduation. So high school grad could be converted into see guys, notice one thing. Since I had got many values here, I converted into a form of a list. But here I've got just one value, so I will not take it in list. I will just simply take it in commas, and I can just replace it with something called high school. Okay, high school. I can just write it here, high school. Next, I will again take this df.education. So what I do is I will just copy this entire thing because this has to be repeated. And I just do this here. Okay, control V. It has not been copied. And just paste it here. I'll paste it here. Okay. So now in this, again, we will go on to making a list of something more. Now you see here that we have got something called associate, VOC, associate, ACDM, and so on. So I just copy this. Okay, control C. And ACDM and this professor's school, I will combine it together and make it into higher. Okay, because I don't know what specialization is this. So many specialization. I'm not bothered about this. What I'm bothered about is just converting into more meaningful and sensible data. So we just come here to associate. Another was ACDM. Yeah, ACDM. Then you have here professor school. Just if you are not remembering it, go and copy paste it from there. And there was also called some college. Okay. And then what I want to replace it with, I want to replace it with some called higher education. If you want, you can write, but doesn't matter. Okay, so now I replace it. Another thing, now only few more to go, guys. We are almost there, and this is like bachelor's. Okay, so in bachelor's you can replace it with, either you can leave it bachelor's as such, doesn't matter, or you can just write here undergrad, right? And again, if I just okay, then you've got one more thing. It depends upon you whether you want to replace this or not, but I'm just replacing it for the convenience sake. And then I've got masters, and in masters what I do is, again, I replace masters with something called graduation, right? What is this? All right, and then you've got one more, and that is doctorate is also there. So I would just here doctorate, actually this is doctorate. Okay, doctorate, and here you have this, replace it with doc. So this is about this thing. Now what you do is you just hit shift enter. Now there's another thing which we can replace is with the marital status. As you can see, there are like husband occasionally present, husband occasionally absent, and so on. So I think we should make a little more sense to this, and just let's do it with the marital status also. And again, marital, I write here Marshall, I don't know why, marital status. And you have here df, right? Again, marital status, I don't know, you call it status or status. Replace it with what? So I will replace a few things here, and there are a few values which you just follow with me and we can just see this later. And this is like married, and that was CIV. Okay, CIV. And this was spouse. I don't know what does this mean. And some complications. So I just remove these complications into a more convenient this thing. I don't know, this married CIF and married AF. The point is that they're married, right? So we just write here married. That's all. Why to complicate matters? So we just make it more sensible. Okay, now again I will take the same thing here and dot replace, and I'll just copy paste it here. So what I want is, again, I would replace it with what? I'll make a list again, and there are certain this thing to be replaced. Like I will take here like there's one known as never married. So let never married be remain as such. I don't know really whether we should, and this could be like not married or unmarried, you can write here. Next could be replace. I will replace with another thing, and now you've got a list of something like divorced, right? Okay, separated, divorced, separated, widowed. They can come into one category. I don't need to have so many categories for the same thing. And there is one more here called married spouse absent. See, again, complication. Married spouse absent. Thank God they don't have this occasionally present, occasionally absent. So now what I do this is I will write here others. Okay, so this is done. And one more another thing to be done here is you can change it with relationship also, but I'm not concerned about that. Let's just do this income. For this income, since I have got income as greater than equal to and less than less than equal to 50 and greater than 50. So what I do is in this income, again I will just map it to 0 or 1. So I write here income and df. Okay, I can just write here df dot income, or I can write it in that form, I can write it in this form, both are same. And I write here df dot income dot replace what? Replace the sign, this sign that this is replace the sign greater than equal to less than equal to 50,000, and you replace this with 0 and df dot income equals df dot income dot replace this what? Greater than 50,000 to, again this is in the form of a string because this is object data type as we have seen before, and I want to convert it into numeric data type. That's all. I mean binary, but not to bother much. Okay, right? Map it. Now what we do is we just check it. So we just check the values now, and you can see here that the income is converted now into 0 and 1, more understandable format. And you can just find here we have done something with this marital status. And now if you want to check here that I'm just checking it. Let's see what just comes out. You can check. So now we have just changed everything, and now you can see this marital status has been converted only to 3 columns. If you want to check about, like, we have done it with some education also. So you can just check this, that in education I have got that this value counts, and I have just decreased it. Okay, so this is how we have really dealt with this. You can deal it with husband and all these things also if you want. Race, let it be the same, because race is something, it will convey some information. School, marital status, and income was being dealt with to make it more meaningful. Now I think this is going to be a long video, guys, so in the next video we shall discuss about visualization, and we'll go to the model building. Okay, visualization and the model building process. So stay tuned for the next upcoming part. So hello everybody, and this is the second part of the adult UCI dataset, and we will jump on to data visualization and model building process. So without wasting much time, I'll just give you a brief of this adult UCI, that we have to predict that the adults making income, they have to predict the income is whether it is greater than 50,000 or not. And we have loaded the libraries. This is the data set, which has like around 48,480 for 42 rows and 15 columns. We have dealt with the columns. We have seen the value counts. We have replaced this question mark with mode, and we have seen how to do that. Then we've done some feature engineering. We have reduced few columns of education, marital status, and the income. And now we will move on to the data visualization. Actually, firstly, I have to show you something regarding correlation. Let's figure out what is the correlation. And this correlation is for the numeric data. These are the numeric integers which we are seeing. And we see that the figure that there's no as such high positive correlation. It's just normal to moderate correlation among variables, and with income and age, and as you can see, this is negatively correlated, negative sign. So we don't have to bother much about this because this is not so much of a concern. And if you want to plot this, we will use heat map for this. So we will use this heat map, and in this I will write df.corr, and in that I would take a note as true, because a note will give me the values inside. So I will use this, and let's see this. Okay, so you can see this, the correlation, all the values have been written inside, and how each feature is linked with the another. Income and age has 0.25 correlation, so this is figuring somewhere here, which is weak. That means it's like if you've got greater age, your income might possibly be into the brackets of 50,000 and above, but we have to figure it out. It is not that evident from this. So this is just give you an overview about the correlation, that there's not so much strong correlation with variables, but yes, there is certain like weakly correlated correlation that we can see here. Now I come to another part of it, and that is we will find the shape of the data, and that is through histogram. We will find this. So for this, I have to plot the histogram for the entire this numeric data. Histogram is being plotted, and then I will go for fixed size. Fixed size equals to 12,12, and here you've got layout as 3,3. I'll show you how this layout works. First, let us just see what is in store for us in this, and how does this comes out, this histogram. So you can see the histogram now. You see that we've got around 7 variables which have been plotted. Age, and you can see the distribution of age here. This age is spread from like around age from 17, because we know that from description it is 17 to 90 years, and the most of the age group lies in the bracket of 20 to around 50, right? Similarly, you can find it for capital gain. It is from 0 to somewhere around 1000, 10,000 or so, 1500. Capital loss, and these the values you see here, which are really small, these are also outliers, and we will see these outliers separately with box plot. And similarly, you can see this hours per week. So maximum people working in this bracket, in this range, like around 25 to 40 hours per week. And few are really going extra miles, like around 99, 80 hours per week. So they are really very hard workers. Okay, and there are very few which who do not even work 1 hour per week. Okay, luxury. Okay, so this income, as you can see here, we've got this people who have got like less than or greater than less than equal to 50,000. It's greater than 35,000, and the people who have income which is greater than 50,000 lies somewhere around 11,000 or so. So this is how you can infer from the histograms the count and the frequency of its occurrence. Another thing, the layout thing, if you want to observe, now remember this thing, 3 into 3 is 9, okay? And the layout is like 3 into 3, 3 rows and 3 columns. What if I change this to 3, comma 2? It will give me an error because it must be larger than the required size 7. We have got 7 features to be plotted, but I am giving it a feature of 6. So I need to increase this. Either I increase this to 4, so that means there would be 4 rows. Okay, so there will be 4 columns and 2 rows. This is how it has arranged itself. Now what if I just reduce this to 3? So this will give me 3 columns, and here I will increase the rows. So rows have to be increased in such a way so that it is greater than 7. 4 threes are 12. If I use 3 3, that makes sense. If I use here 2, that means 2 rows, and I increase the columns to suppose 4 or say 5, then it will be congested, it will just accumulate here. Let's see what happens here. And the figure size is 12 comma 12. It becomes a little congested, it doesn't look nice, so I will just reduce it, and I just restore the previous layout of 3 is to 3, 3 comma 3, and this looks more nicer. Okay, now for the box plot, you just keep experimenting with things would be clear. So then box plot, what I do is I would use this df dot plot, and in this I will use the kind equals box, and the fixed size is, again, I can give 12 comma 12, 15 comma 15 as per my wish, as per the features it is plotting, number of features. And this layout is again 3 comma 3 because there are 7 this thing, and it is plotted for numeric data, and share x is false. I'm not sharing the x-axis, and I will write here subplots equals true, and you have to mention this thing. And I just hit shift enter, run this code, and now I get the outliers. These are the extreme values in my data set. So I have it in almost all numeric data. Like age, I have this extreme values, which is like around the most of the age is lying in the age group of, like as we've discussed in histogram also, from 20 to around 50, but you have people who are in the working age group who are above 50 to exceeding to 90 or so, and very few people here like in the 80 to 90 age group. Similarly, you can find here with the educational number and hours per week. So most of the people are working around like 40 hours per week or so, and these are the outliers who are really not working at all and who are putting extra efforts. So we can see it here with the box plot, the outliers. Outliers affect our data set because it kind of make bias predictions, give more weightage. Now we come to Plotly, and we shall see how to plot with Plotly, and we'll be going with the pie chart. Okay, so I will use pie to show you the distribution of the data, and we will use values as educational number because it has to be numeric, the values being plotted, and in the names I will use education because I want to show you the percentage of education. And I can use the title if I want, and I can just write here percentage of education. Just to make it short, I'll write here percentage of education. And I can use the color discrete sequence, so I just use this. I had pressed shift plus tab to show you what is there, so I just copy this color discrete sequence or control, and I will paste this here. So this is color discrete sequence, and this color discrete sequence comes out to be, I can use the syntax as px dot colors dot, I'm using qualitative dot, I'm using t10 here. Let's see what comes out. Okay, what is it? Values. Value of values is not name in column of data frame expected. Okay, I have written the wrong spelling. That means educational number. Okay, this is not underscore, guys. This is this. Okay, yeah. Done. So now it should plot it, and when it will plot, I will quickly take you to another plot, show you how it plots. Plotting will take a little time because it is plotting the education number and everything. So here we are with this. Okay, we have reduced a few dimensions, a few features in this education column, and so we've got just reduced it to like higher school, undergraduation and all. So you can see that the higher education has the highest share, that is 33.1%, and followed by this high school, then undergraduate, graduate, school, and the doctorate. So it's the lowest, like 1.93% of doctorates, right? Okay, so this is what your percentage of education is showing in this plotly chart. Now I will show you something with SNS. Now let's come to SNS count plot. Since we have got various categorical features, I can use count plot here, and I will find here race because I want to see how this race is interacting with different things. I will see here hue equals to income, and I want to see the income of this. Go to the data is df, and I'll use the palette, and the palette could be like, give it magma. Let's see. Okay, now why I use this semicolon, can you see this matplotlib access subplot? If you don't want this, just use semicolon and this will be gone. Okay, you will just have the plot. So you can see here this race being plotted on x-axis, and the count you can see here in y-axis. Actually, this count plot is a kind of a histogram for the categorical variable because I want to see the count, and I see that the white have got the highest income, and they are highest in the number in this data set. So we can find that their income is high in both the cases. Then black is in the population, and then we've got Asian, Pacific Islander race, other American, Indian, Eskimos is the lowest. Okay, okay, so this is the data which we can see here. Now you can experiment with this, like you can have your occupation and let it be income, and you can see, okay, this is a little haphazard, so I can write here, let's take here education. Okay, so you can see in education you've got hue income. Now if you don't want this, you can just play around with this. You can take here gender, you can play around with the palette and just take here like I think I can take seismic. Seismic, okay, right. So you can see that male and gender and their count in each of the education category, and you can see that females are much lower as compared to males, and you can see in high school you've got the highest number of males, and then followed by this in higher education. Okay, so you can just experiment with different and various features here. I can use race, education, gender. I can change hue and see the variations with that. Now, without wasting much time on data visualization, I would come on to something. Now, if you want to more explore more, please visit this website. I have done it in more depth and description. You can just see here what what all things need to be seen here with data visualization, and it's I would say, okay, so you can just see these visualizations here and the key findings and observations which are also being written. Okay, so now we come to the model building process, and for model building we have to just first of all, I'll give you go by step to step, and I'll explain you how do you really do this. And what I do it, I create an object called X, and in this I will store df dot drop, because in my X I have got the entire data. I have also got the output here, that is the income, and I don't want income to come because I will store it in Y, and I just have to train this X to map it with the output. This is what we do in machine learning. So I have to first separate it, and X is equals to 1, and in Y object I will create this df. I will put this income, this object, right? This is the dependent variable and X is the independent variables. So you just press shift enter. Now what you do is you come on to some feature scaling. You have to scale the data because you have to make sure that each and every um, values are of the same magnitude, and none of the features are given more importance. So what I do is I will import a package from sklearn, from sklearn.preprocessing. What you do is import standard scaler. I'm using standard scaler, and also you import label encoder here, right? Label encoder. So when you're done with this, what you do is you can make a copy of df.copy and copy one, store it. It's a good practice if you do it, because your df will not be disturbed with this. And then you've got df1 equals df1 dot apply. What will I apply in this? I will apply label encoder here, because this label encoder will bring all the categorical values into either 0 or 1, or change it into numeric format, if I can say. This will also help this code make it more machine readable. Label encoder does that, right? So okay, I'm halfway this transform, and then I will see df1 dot head, and this is something like that. So you can see here that the education has been converted into like 1 2 3 4 and so on. The work class was categorical, it has been converted. The occupation had also been converted into numbers. It has assigned numbers to each categorical variable. You can see marital status 0 1 2. This is how it works. So label encoder just fits your data into machine readable format. Okay, the native country, can you see that it has assigned values for each of this? Okay, now we come to something called SS. I create an object wherein this is the standard scaler. This is standard scaler, and this will be dot fit. And what will I fit here? I will fit my df1, and in this what will I do? I will drop. Okay, I've already dropped this, but again it's like df dot drop income, because I dropped it in for x1, that is df, and now I'm dropping it for x is equals to 1, df1. Okay, not finding axis. Okay, this has already been dropped, right? So it has not found, that's why it's not finding an axis. So now what I do is I will write here x is equals to ss dot transform. I will transform this df1 dot copy, df1 dot, okay, transform it, transform this drop. Let's see how it works out. Income xs is equals to 1, and here y equals to df. Here I will write income. Let's see. Okay, standard scalar I have defined, standard scalar I haven't defined standard scalar yet. Okay, I will define the standard scalar and I make an object called ss is equals to standard scalar, right? Yeah, so I create this standard scalar, transform. Okay, I usually do the spelling mistakes. Standard scalar dot. There are some glitches here which I just need to fix it. Just bear with me. I think this is df1 dot drop and I have to drop this, and it is dropped, and this is income, and I will take on to x's where it will locate it as 1. Okay, finally this has been done, guys. So what was the problem? That was I created an object standard scalar, but it was asking for fitting it. I have simply transformed that. So I had to first fit this and then you perform transform. So this is a thing that first you fit the data set, and I have fitted this data of df1 and have sorry, this is again like df dot drop. Okay, then I have fitted this data in df1 and df1 dot drop. Okay, and after this, after fit we perform transform. So this has been fitted. I have dropped the income column here. So now and I have told it to transform this data, drop this income, and in y you store this income. Since I have created df1, I had to do it again. I did it previously for just df, but now I have to do it for df1 because I created one df copy just to be on a safer side. So now it has been done transformed, and now we will perform some train test splits. So from sklearn.model selection, what I'll do is I will import train test split, and here I will write here xtrain. This is the syntax: xtrain, then you write xtest, then you write here ytrain and ytest. Ytrain, ytest, and give the train test split size. So then you've got train test split, and here you've got split x, y, and what is the test size for that? I will take its standard size, which is a practice like 0.3, 70% of the training and 30% on the testing data. And I will also take some random state, and that could be like 40 or 30. It is your wish. You can take 0 also. And you run this. Then what you do is, now I will be using logistic regression in this, and I will explain you two models here, two classifiers, that is logistic regression and random forest. So we'll go with logistic regression first. It is used for binary classification. Don't get confused with regression here. So I will just import this first of all. So from sklearn, I've not done it in the starting because I wanted to show you from where you want to really import it. So from sklearn.linear model, you find this logistic regression. What I do is I will import logistic, be virtual with the spelling. Okay, logistic regression, and then you can go ahead again with from sklearn.metrize. I will also measure the performance of my classifier, that is logistic regression, with matrices. So I will use here matrices, and I will import. I will see the accuracy of it. So I will go for accuracy score, and I will create an object called LR. In this I will store the logistic regression classifier. So I will write here logistic, and this will be logistic regression you store in this. And then what you do is I will write here and an object I'll create model, and this could be LR dot, again I have to fit this model, so I will fit here. What will I fit? I will fit X train, my X train, and Y train, because I want to train the model on this. So I will fit X train and Y train, and then I will make predictions. So I will make prediction, and this prediction would be model. On this model dot predict what? X test. This is my X test prediction. I also want to show you something like model dot predict. You can add one more thing if you want to test this. What I'll write here is I will write here print accuracy. I'm just like using the short form accuracy of or accuracy on the training data set. So I'll write here accuracy on training data, and this will be somewhere around. I want a format for this, and I'm giving it a format. I want till 3 decimal places, and floating point variable, and then I want the format. So I will write here more dot format, and the object lr dot score, and this in score I will write here, let's take X okay, here X train and Y train, right? So what I'm doing is I want to print the accuracy of everything, so that's why I'm using this. And again I will copy and paste this, and here I will change here from training to test data, and the format will be the same. And here dot format lr score, here will be X test and Y test. Okay, so I'm making predictions on X test and Y test, and let's just run this. So this you can say that on training data set it is performing something around 83.8, and on test data it is like 83. This is my logistic regression. And the next thing I want to show you is about random forest. So just let's just do for random forest and check whether is there any improvement. So random forest classifier, again we shall just call it and see from the module from sklearn, again dot ensemble, they are under ensemble, and I will import random forest classifier, right? And then I'll create a model for that. I'll create an object for that, RFC. In that I will store this random forest classifier, and I will call it as and when I need it. So I just store it, create an object, and then I will create model 1, and in this I will use this RFC, this random forest classifier, and I will fit it. What will I fit? I will fit X train, and I will fit Y train. Okay, and then I will make prediction, and prediction 1, say, because this was prediction 1, so this is prediction 1, and here I can write model 1 dot predict. It will give me the same thing, you know. I can just write here X test and you can just run this, but I also want to show you that I have to print this entire thing. So I would print it here, Control V, and here instead of LR I can write here RFC, that is random forest classifier, and here could be RFC, and then you can just go ahead and see what what accuracy is this giving me on training and test data set. And till the time it is running, I can simply just um, from sklearn.matrices, I have to import confusion matrix, because I want to explain you about confusion matrix, and this is the right time to delve into confusion matrix. It is not confusing, but uh, this requires a little practice to understand confusion matrix. Okay, I will import the classification report also. Classification report. And accuracy, since we have already done, so I will not use that. Okay. So now you just again spelling MET. Okay, pardon me for this. Classification. Okay, it's not having some self-correction properties. Something has to be done for this. Okay, so you can see here that on training data set I have achieved 100% accuracy with the random forest classifier, and in the test data it is 85% accuracy, which is greater than this logistic regression, that is 83%. You can try with different classifiers, like you can use decision tree classifier, you can use KNN, SVN, SVM, and so on. But I have right now, we just stick to this thing. And now let's begin to print our, I'm doing it for this only, so I'll print the confusion matrix. Confusion, what is it? This is confusion matrix I will print, and I will print it on what? Y-test and predictions. Prediction 1. I can do it for the upper prediction also, but I will take this prediction because this is giving me a good accuracy. So I will use this prediction, and I will print the confusion matrix and also explain you what does this mean. So you can see here that I am getting 10332, 806, 1286, and 2229. Let me just print the classification, again spelling, classification report. And in this classification report I would just use what? Y-test again, and Y-test and predictions, making it on predictions, prediction 1. Let's see. So can you see this classification report now? I will use classification report and confusion matrix to make you understand what is this confusion matrix all about. You understand this precision and the recall. So precision, how is precision calculated? Precision is actually true false, true positive upon true positive. I'll write it down for you. So this is actually true positive divided by, I can write here, true positive plus false positive. Now identify here what is true positive and false positive. Now since I have not assigned it, now you have to figure it out what is what. So I will just show you with the calculation. I will write here so that you understand and follow with me. Precision. Now we are finding the precision, and let's just, this is interesting. How do we do this? True positive for the first class I'm finding. Okay, this is actual and predicted. I'll be coming up with this confusion matrix theory video to make you understand how this really works out, but the practical session, understand this thing first. This is true positive. I will use here 10,332, and you divide this by, again, true positive, so we don't have any problem because we know what is true positive. And then you come to false positive. What is the false positive rate? So this precision tells me the correctly identified cases or instances that my algorithm has, or my classifier has, rightly predicted, only the positive instances. So false positive, what is false positive here? False positive is 1286 here. Okay, so you write here 1286. This is your false positive. So you go for precision like this: true positive plus false positive. So when you print this, you will get here 88.9. So that is right, round approx 89% precision. That is what we are getting for the first class, and this first class is less than equal to 50,000, and I'm getting a precision of 89%, that my classifier is able to predict correct instances, which is 89% precision. Now I call about recall. Recall means the negative or the missed out positive classes which my algorithm has really missed. So if I just tell you about the formula of recall, this is true positive rate, and this is important to identify because here you find out the missed instances of your classes. So this is about true positive divided by, I will use here true positive plus false negative. The negative, that means the missed instances of my class. And now here, how would you identify this thing for the first classes? I will print here recall, and I'll go with this thing. I'll go with true positive. Again, I know true positive, I have no problem. I can just simply write here 382 and I divide this by the entire thing. Now true positive plus false negative. What is true positive here? Again the same thing, and this is 10332 plus false negative. Now come to false negative. What is false negative here? This is false negative 806. Okay, and you print this. So this is 92%, 92.7, round about 93%. Now this one, remember, this one is for the first class. What about the second class? The first, this is the negative class. Now for this again we have a different formula. We have the same formula, but we will just interchange the values. Okay, so we just interchange the values. I just want to see this confusion matrix. See, these are closely linked. The classification report will give you the precision and recall, but if you have got confusion matrix, you can find out precision and recall. And this is how I am telling you how do you really find this. True positive, you locate true positive, you locate true positive, false negative. So what remains here? This is false, this is true negative. Okay, so I just mention it here that this is what, this is true positive, this is false. So you can just see this and correlate this with the numbers. Now I come to for the class, for other class, and that is 1, and this means that this I'm predicting about greater than equal to 50,000. Now again, now I have to print what I want, precision. So I'm just calculating the precision here, and this precision would be what? Again, true positive upon true positive plus true false positive. So here I know the true positive. What is true positive here? This one for this class. Okay. So I'll use this here. That is, so you have to identify it, and you will understand it when you will do the practice. When you will do it yourself, you will start understanding all these things. How does it really work? So I'll use this here. Don't just tighten up. It is easy once you start interpreting this thing. It will be easy. You have to write it down and see how it works for you. So plus 806. Okay. And I will just print this precision, and this is 96%, as you can see here. Where's my classification report here? Okay, no, this is not 96%, this is 73. So I'm getting something wrong here. I'm fitting something wrong, some wrong value here. Okay, yes, here 22291. No, still it is wrong. It is not 96. It has to come 73. So there is something wrong. 222806, and this has to be for the other class precision 2241, 224, 222229. Have I mentioned 2229? Why is it 1229? Okay, yeah, fine. 73. I added extra one here, which was not to be added. So now you get to recall. Okay, and in this recall, I will add what? True positive. Again, 2229. I'll be cautious this time. And I will add what? Same 2229, and now I want the false another number, and that is here 1286. 1286. Okay, so I'm getting recall of 0.63 for the another class, and this is what my classification report also says. So the correctly predicted instances for the second class by my algorithm or classifier is 0.973, and it is giving me a recall of 0.63, which is not that bad, but it is not that good also. That means I'm likely to miss a few instances. Okay, I'm likely to miss instances in this class, and you can see these missed out cases here, 806 and 1286 wrongly identified cases by my algorithm. And this F1 score is nothing but a harmonic mean between precision and recall, so need not worry about that. So this was about the accuracy, or you can say the confusion matrix, which has been explained in detail here with formula, and this has to be taken in unison. What is confusion matrix and classification report? One can derive confusion classification report from this confusion matrix itself. Okay, support penalizes the wrong instances. If you are making wrong instances, you are being penalized for that. You are punished for that. So this is about this thing, the accuracy. So random forest classifier is giving you good accuracy on test data, 85%. This can further be boosted with gradient boosting. You can use ad optimizer and other different ensemble techniques to boost or to improve this accuracy. Also, you can use hyperparameter tuning. So there remains a lot of scope to improve the performance of this basic model. This was just a basic model. You can improve upon it if you are really interested in it. So this was about the model building. We've dealt only with two. If you want more, you can just visit the website and explore different regression techniques here. Okay, so that's it for this video.
Hello friends, and in today's video we'll be discussing about the wine data analysis. So let's start with the analysis. First we will load the basic libraries here. So I have already written it. So we import NumPy, Pandas and two plotting libraries, that is Matplotlib and Seaborn. So this is how we write it, and we call them as respective by respective names, right? So this is the convention, NP, PD, PLT, SNS, that's how we follow. Press Shift Enter. Then this wine dataset is already been provided in the sklearn. So sklearn comes with many datasets, and wine is one among them. We've done Boston and Iris in our previous videos. Please watch it. They were also in sklearn. We just loaded it. So we will load this. So what happens then? We create an object, and in that we load this wine data, and then you see wine. So this is the data which has been loaded, and we see this is data, this is target, we've got target names, and we see here class 0, 1, 2, 1 and 2. So that means there are three types of wine here. And let's explore further. We see description, and we see so many things which is not understood. Okay, fine, then let's make it more easier to understand. So we can just see here that okay, there are feature names also, that means they are columns. So what I write is here is wine.feature names. So this gives me, these are the feature names as we have seen there. There's alcohol, malic acid, ash, magnesium, flavonoids, and so on. Now let's just check our target names. We've seen that there are three classes, 0, 1 and 2. And when we see the description of it, we will see the wine data set, and the data characteristics are, as you can see here, that the instances are 178, that is 15 each class. These are rows, and 13 are the, you can say, columns. Okay, and one is a class in it. So we can see this here, and the class is this, and they have given the statistic summary also, that minimum, maximum value and standard deviation of each of this feature. And do you have any missing values? No. And they have also given that class 0 contains 59 values, class 1 has 71, and class 2 48. We will explore it in our data. Okay, it is just the description because it has already been there. That's why we know it. But suppose you have an unknown data, how do you understand? How do you derive information? We shall see now. Okay, press here so that it will go. Next, what we'll do is we've seen that our data is unorganized and it's something like this. So let's give it a good shape, arrange it into a data frame. So we use pandas for this. So we convert it into pandas, pd.data frame, and we get this data, bind.data. And in columns, we will give these feature names. And we see it through df.head. And this will give me the above 5 values by default. Okay. So this is what we see. The entire thing is there. Now you see here the target is not here. Class is not coming. Okay. So, and we see the tail, that means the last 3 entries, because I mentioned 3 here. So you can see here the last 3 entries. Okay. Now if you want to see the shape of the data, the shape will look like 178 rows and 13 columns. Now what we do is we will add the target in our data frame. So this is how we write it. In df target, get bind.target. So bind.target will be added in the last column, and when we see this data in df.head, the first 5 entries, we will get this, and this is the target which has been added, right? If you want to see the shape of the data, this will be 14 columns. And you can also check the columns by df.columns. You'll get all the columns here. Now we'll check the data types. So data types is important because it will tell you whether it is an integer or some object or a category. So I write df.dtypes, and this will give me the description of all the features, and they are in float, and the target variable here is integer form, right? And let's just see whether is there any null values, any zero here. So we write is null dot sum, and we see that no, there are no null values. So that's good that we don't have to fill now any null values because there are no null values. So data pre-processing, data cleaning is not required much. This is already a clean data set. Now we will see the target.value counts, and this is what we get, that class 1 is 71, class 0 has 59 instances, class 2 has 48. Okay. Now if you want to show it, how would you show? I will use sns.count plot. In that, I will see 0, 1 and 2, and their count has been displayed. Greater than 70, 0, that's less than 60, and 2 is, less than 50. Okay. So we have plotted it. Now let's see the correlation among various features and with the target. How are they related? So I set the figure size as 12:6. This comes with PLT, matplotlib. And in SNS, I have this heat map. In this, I plot this correlation. And this is the C map. I have given the color. You can see yellow, green, and blue. And I plotted this. This is how it looks. So you can see this high variance here, very high correlation, 0.86, and this is between total phenols and flavonoids. Let's check out with our target variable. So we see negative relation with alcohol, ash, magnesium, total phenol. See high negative correlation with flavonoids and total phenols with the target. And also with this diluted wines and proline and hue, they're negatively correlated with the target. Right? So negative correlation means them moving in opposite direction. If one is high, then another one is moving in, smaller values of one means higher values of the other. And these are positive correlation. That means this alkanicity of ash, malic acid, non-flavonoids, phenol, color intensity. These are positively related with the target. So we can find the correlation here. Okay. After this, let's just go on to plotting the SNS pair plot. This pair plot helps us to understand the relation between two variables, whether it is linear, non-linear, with the help of scatter plots. This is basically a scatter plot, and as you can see, we find this linear relationship here, and when you map it, this linear relationship, we go further and check, and highly linear relationship has been observed. This is flavonoids, right? And when you check, this is total phenol, and when you map it down, this will again come out to be flavonoids and total phenols. That means they have high linear collinearity. They are very, positively related with each other. So, and you can see various scattering, but it is not easy distinguishable between classes 0, 1 and 2. So let's see further. So now I will use this histogram plot. All right, to see the shape of our data. How does the distribution look like, and how many the count of each bin of this alcohol. Like suppose if I see this the alcohol part, then between 12 to 14 I have the highest range here, and in middle I have got this highest range of alcohol here, right? So the bins tell me how much distribution I have. Ash, similarly, you can see which part has which, how much high it is, how much low it is, what is the distribution, and whether it is screwed, exponential, or it is a nominal curve by well distributed, normally distributed. So we can find it out from here. And you similarly see proline, there's a lot of variation. Total phenol has also various variation. And so we can see that yes, outliers are also here. See, less values you can see here. That means they are extremely like huge values which are affecting my data. Even here we have outliers. Here we have flavonoids. They have. So let's see. The box and whisker plots give me a good idea about the outliers. And I plotted kind is box and subplot true. This is what I write down, and this is what it gives me. The layout is 4 and 4, and the font size I've given 8, and figure size is 12, 12. So 4 in each row and column. So you can see these circles outside the figure is the outlier. So I can see the outliers in many of the features which will affect the data. See, color intensity, hue, they have these outliers. That means they are outside the normal spread of data, and these whiskers are the spread of my data. So alcohol is finely distributed with symmetrical data, right? But malic acid has median. So this box plot shows me certain values. This is the median. This is 25% data and 75% data. This is 50% of the data. And these whiskers, so this is like positively screwed because the right whisker is much bigger than the left one. And we've got outliers also. So this is giving me 5 informations here, right? And next we go on to seeing what else. So target, you can see very symmetrical, right? Finely distributed. And proline is also fair enough, no outliers, as you can see. U has one outlier. So what is the effect of outlier in a model? Actually, the when there are certain like extremely high and small and large values in a data set, the model learns it. And when it learns it, it tries to overperform, overfit the data, and it learns the noises also. And so it does not perform well, it does not generalize the data. So it will not be a good fit. It will not, I would say, understand or map the real world situations. Okay. Now I can just show you how to just do it for the individual plots. So for SNS this plot, like for target, if you see, we know the target, we know by count plot how many are there. So like more than 17 target 1, so it's like here, and for 0 it is here, class 0, and for class 2 So the distribution plot shows the histogram and the KD, that is kernel distribution estimation. Okay. Next, I have used this bar plot to show you the relationship between the target and the flavonoids. So you set this figure 10:6 so that it is visible and you can visualize it better. Use bar plot for the target in x-axis and flavonoids on the y-axis, and go for get the data from DF, and palette is coolworm palette. Then we see that flavonoid for class 0 is much higher as compared to 1 and 2, and it reduces for class 2, right? Okay. Now let's see for the another one, and this is for target and alcohol. See which class has greater alcohol. Class 0 has the highest amount of alcohol, then we have class 2, and then class 1. So wines having different you know quantity of alcohol in them. And then box plot again for target and ash. So this box plot will tell me outliers in ash and target. So I see in target 1 I have got, and in target 0 I have, but in 2 I don't have outliers. Okay, and these are negatively correlated. So now I have also visualized this by joint plot. Let's see how it looks with target and total phenols, and the kind is hexagon. So you can see it for target 0, class 0, that the total phenol, and how does it look, that that so for target 0 I have it in the higher range, and total phenols for target 1 again I have got it in medium range here, between like 3.5 to 1.5, less than 1.5, and for 2 total phenol value is much less. This is what this histogram is also showing me, total phenols. Okay. Then I come to bar plot again, and I plotted this. You can try with different features, so for good practice. And this is alkanicity of ash, how much alkaline it is. So this is so class 2 is having more alkaline as compared to 1 and 0. So you know makes sense, because it has less amount of alcohol in it. This has high amount of alcohol in it. Okay, so now again the bar plot with malic acid. So this has more malic acid as compared to the other two. Now when I come to the another one, this is for magnesium, and again we see that 0 has much magnesium as compared to the other two. So alcohol, more magnesium, more ash, right? So you can determine the quality of class 0, that has more magnesium and more alcohol, malic acid, etc. And then we plot the target for hue and target, and we see that the hue in again 0 and 1 is much higher as compared to 2. Now this again I have experimented with something called joint plot, and I have plotted for the target, and we see that again for the hue, so you can see for class 2 it is less as compared to 0 and 1, which is comparable, right? And then we go to color intensity, because that was left, so I just did that also. So we see that the color intensity varies with 2, and it is higher in 2 as compared to 0 and 1, right? The color intensity. So this is for the total meters, and explaining what do they really do to a model, exploring various plots of SNS, like distribution plot. This plot with KDE, we have seen bar plots, and exploring it for different variables, and we see box plot, bar plot, and joint plot. And now we come to model building, the final stage of this project. So what I do is I will import certain metrics from my sklearn. So what I do is from sklearn.model selection, in model selection, I have this train test split, I have k-fold and cross-val score. So these are resampling methods for helping me to dividing my data set into train and test split, and this k-fold and cross-val score will help me to shuffle my data and perform train and test, and it is much better than simple train and test. So for more resampling techniques, please see the previous videos, and links will be provided in the description box. Next we see that the matrices, and again from sklearn I import confusion matrix, classification report and accuracy score, which will help me to evaluate how my model algorithm has really performed on the data. Then I import the model. From linear model I import logistic regression. From tree, decision tree classifier, since this is a classification problem. And sklearn.neighbors, you have k-neighbor classifier, discriminant analysis for LDA, discriminant analysis, and naive Bayes from import Gaussian NB, and from SVM we import SVC. Now the next step will be to split our data. Okay, what I do is I split my validation data set, and what I do is for X I have selected only the 13 starting 13 columns, right, all the rows, and this is the function I'm using for slide. This is called slicing, and I take the first till the 13 rows, right, and for Y I take all the rows and the last one, right? And the validation size is 0.33. That means it will be splitted by this 70 like 0.33% will be my validation data set, and the rest will be my training data set. And the seed is 7. That means I fix the value as 7, so that again and again when I run this code I get the same result. So I make these x train and x validation, pi train and pi validation. This is only the way how to write it. Then train test split I write. I can also use here x test. Few people use here x test, but you write validation, anything of your choice. Then in train test split you split x, y, and the test size is 0.33 validation size, and the random state I can either write here 7 or I can define it as seed. Okay, then if you want to check your y, so you just write print y, and you can see this is the column which has been selected, which is right, the target value. And if I want to print the x train shape, this is 13. Okay, it has taken these 13 values, and y train shape is 119. That means the last column, and it has 119 rows. Next is x train if you want to see. So this is what the x train looks like. Okay, then we'll check the algorithm, which algorithm performs the best. So to cut down and to save time, I have just created a model with an array, empty array, and what I do is I create a tuple. Inside that I create this object name and the classifier of the same, right? So I just name this classifier and an object for that, and I append it in the model. Similarly I do it for all. So models.append, this is the name of the object I want to call it, and the logistic regression, this is the classifier I'm using, right? Then LDA is the object name, and linear discriminant analysis is the classifier which I'm using for this. And this is how it has been imported. Also I have imported it previously, as you can see from here, linear discriminant analysis. Okay, or different, so I'll be calling the same thing here in my models. So here NB, again Gaussian base, CNN, KNN, cart, and I call the same decision tree classifier. KNN I create the object, I create the classifier. For SVM, SVC, support vector classifier, I call this object as SVM. Now what I do is I evaluate each model, how my model is performing. So for that I have to see the results. Okay, so now what I do is I create results and also the name. So two empty arrays which in the results will be stored. So, and I make a for loop which will go in iteration and will go iterating until I get the all the models result. So what I do is I create k-fold, which will be needed. So this iteration will be going for name and model in models. So what it will do is for k-fold, so the k-fold I will take 10 splits, okay, 10 folds, and random state as 7. And in CV results I will take what cross-val score it will take the model, right? The model, X train, Y train, whatever I size I have described before. And CV is k-fold. This is the CV. That means 10 split it has to go, and it has to take 7, like reproducibility. 7 it will fix the size. And scoring I have taken as accuracy. Right? Accuracy is good here because the dataset has equal classes for each class. So then I do results dot append what CV results you append, and in names you append name, right? And the message you print as name. This is the syntax of it. Name, CV results dot mean, and standard deviation, so that we can compare how is it given and print the message. Then what you do is, so when you've run this code, actually I have not imported warnings. Please import it. So linear discriminant logistic regression is giving me 93% accuracy. You can say the mean, and the standard deviation is 0.53. So we go with the highest mean, and let's see. Okay, the other, so LDA linear discriminant, the highest 0.98, 0.33. For KNN it is less, for SVM it is less, and standard deviation as you can see is very high here. That means you can find here that there's much of a spread and outliers effect here. Naive bias is fine, 95. After LDA logistic regression you have naive bias, and CART is just 91. So we go ahead with LDA, right? It's 98.3. And logistic regression, as we've seen, it is 93. So we go with plotting this algorithm. Okay, so we see LDA nearly achieving 100% of your accuracy here. And then is your logistic regression and naive bias. But you see SVM and KN are not performing well on this data set, right? And even CART is giving low performance, right? So let's make predictions on how it has performed on my validation test. Okay. I make predictions since linear discriminant analysis was the good model. So I have used that again, and I have fitted my X-train and Y-train in that. Then I create an object called predictions. In this predictions, I will predict X validation, and then I will print the accuracy score on my Y validation, which I have not used till now, and predictions, that means X validation. Okay, to see that how is it performing. And then I print the classification report also from same by validation and predictions, and confusion matrix on by validation and predictions. So when you run this, you will get here 98% accuracy, the precision is 1, recall is 1, F1 score is 1, and for each class the support you can see. So like for the first class it is predicting perfectly fine, and we see in the confusion matrix also that there are no wrongly identified or false negative here. But in the class 1 it is wrongly identifying one positive instance as false positive, right? So that's why we've got recall as 0.96 for the class 1, right? Because it gives you the true positive rate recall, right? True positive rate TP plus FN, okay? True positive plus false negative. And for further explanation of this, please visit the video on classification matrices, because it is really important to understand these numbers, what they are telling me. And for class 2 also, again, I get truly predicted that all classes are being perfectly predicted well with my algorithm, and recall is also good. But here you can see the precision is 0.95 only, okay? And recall rate is nice, because that means it has not rejected any of the rightly identified class, right? So this is a good model, and the prediction rate is high. It is 98, and linear discriminant analysis is the best algorithm which works with it, and with the Vine classification data. So we see that all the classes are perfectly predicted, making only little, I would say, wrong prediction on class 1. Rest all are finely predicted. And so this is our Vine project completed classification example.
So guys, today we shall be discussing about Titanic survival prediction using Python, and this is an ongoing challenge or dataset prediction in Kaggle. So what you do is how to get the dataset. Um, in your Google, just write Kaggle Titanic, and then the first link directs you to kaggle.com, wherein you will find this dataset. So this is nothing but you have to predict the survival of the passengers who are on board Titanic. So that's a challenge, and this is just a learning ongoing challenge, and this is uh, for learning basis, right? So what you do is you go to data and just scroll down, and you will find here three files, and just download all. In these three files, you've got train.csv, test.csv, and gender submission, which you have to submit, right? So if you're participating in this competition, then you can work with all these files, but I'll be working with train.csv just to give you an idea about this data set and how do we go about really building the model. So this is just predict survival on Titanic and get familiar with ML basics, and that is what the agenda of today's video also is. So I walk you through the Titanic dataset and the Jupyter notebook. So what I do is I would simply import the basic libraries and load the data. So we'll be using NumPy, Pandas, Seaborn, Matplotlib, and math is not needed. You can just delete it also. So now when you run this, your data set will be downloaded. I mean, the libraries will be downloaded. Now to get the data, you have to upload this file train.csv, which has been downloaded in a zip folder, into your working directory. And from that, you will read this file. So in an object called Titanic, I have read this file train.csv and have seen the first 5 entries of it. And as you can see that we have got some 891 rows and 12 columns, right? Okay, so what are these columns and rows? Let us just see. So these columns are the features which we'll be using for plotting and analysis. So this survived, as you can see here, has got two values, that is 0 and 1. 0 means not survived and 1 means survived. Alright, the passenger class is first, second and third passenger class in which the passengers are traveling. Okay, the passenger ID is there and the name of the person is there, which we will not require actually. The sex of a person is there, male and female, the age, and this is the SIB SP, that means siblings or a spouse which have been traveling. The Porsche is also there, and ticket. They are not so important columns, so I won't be going in detail of it. The fare, the cabin, and embarked. Embarked is the boarding station of the passenger. So this is 3 embarked stations here: SC and Quinston, Southampton, and Cheersburg, right? Okay. Now we see, coming to analysis of the data or data visualization, I can say, and I'll be using simply the Seaborn and Matplotlib libraries here. So what we do is let's just count how many survived and non-survived passengers are there, and we can just estimate that how many, like more than 500 people have not survived and more than 300 have survived. This is what we can infer from this plot. So I just plotted a count plot, basic plot, and from the data Titanic, on the x-axis we've got the survived column. Okay, all right, now we move on to our now the analysis from this would be the passengers who are traveling on Titanic have not survived. The proportion is more as compared to the passengers who have survived, right? Okay, now let's move on to another plot which would show you the count of females and males, right, as per what the survived and not non-survived. So on x-axis I have taken survived status, that is they have not survived and they have survived, and how many of them are males and females. So as you can see that there are more number of male passengers who have not survived as compared to female passengers, and also I can see here that more number of female passengers survived. Okay, this teal color, as you can see, is showing the females who have survived more as compared to males. So that means more males have really died on Titanic shipwreck as compared to females. So they were being rescued. Okay, so let's just come down a little and see more plot on this on passenger class. Let's see how many passenger class like 0, 1, 2, 1, 2 and 3 the passengers are traveling and they have survived. So, okay, so on x-axis we've seen that the passengers not survived and the passengers survived belong to which of the classes. So we see that those who have not survived, those who died, belong to passenger class 3. That means if you are traveling at a low fare in the third passenger class, there are more chances that you will not survive. And if you're traveling in class first and class 2, you will be rescued. As you can see here that the chances for your survival really increases when you're traveling in passenger class 1 and 2, paying higher price. Okay, all right. Now this was the three columns which we have actually explored. Now let's just, with the help of a histogram, we will see the age distribution. So histograms are really helpful when you want to plot numeric data, and here we are plotting this age, and so you can see that this is like somewhere around from more than 0 to somewhere around 80. So that means elderly people, the aged, are also traveling on Titanic, and the major proportion of people are youth from you can say from 20 to somewhere around mid 30s. They are they form the largest chunk, right? Okay, and we've got a few people from like traveling in the age of 60, 70 to 80 years, but they are very low, right? So now again, if you want, let us see the fare distribution, and again the plot is histogram plot, and this is the size and the bins have been set up in this function and inside the parameter. Now as you can see here that this shows the frequency, and here you can see the fare distribution. So we see that the most of the tickets are bought under the fare 100. All right, that means these are the people who are traveling in passenger class 3 and mostly from the age group of 20 to 40, and they have bought ticket which is less than 100. And those who have bought ticket more than like 200, 300 and 500, there are very few passengers, and I can really infer from this that these passengers, since they bought high ticket, might belong to elderly group, in the group of 60 to 70s, right? Because they're traveling, they are less in number, and also they can afford higher prices. So but that cannot be said formally, but yes, I can infer it from the data, okay, from this plot. Now I will show you the siblings aboard. So as you can see that most of the people do not have any siblings aboard, so they are traveling individually, but there are few who are having like 1, 2, 3 and so on siblings on board Titanic traveling with them. Okay, now this is another column Porsche, which is numeric in data type. So I've plotted the histogram plot. As you can see here, Porsche, it's from 0, and you can see the frequency of it. So the 0 to this thing is coming till around 700, 0 to 1. Okay. So now I come to another thing, and that is data wrangling, which is important if you have to find out how many null values are there. So for that we use the function called isNull.sum to find the total null values present in our data. And we see that in the age column we've got some 177 values which are null, and in embark we've got 2, in cabin we've got 687. Okay, and if you want to plot this, we can just plot it in a heat map to show the null values, and we see that the cabin has most of the null values, and we've got it in age. Since embarked has very few, like only 2 null values, it has not been shown here properly, not displayed. So now we have to fill these null values, and also we can drop a column. So let's just do some data processing. And before that, there's a box plot here which shows that and especially for P class, passenger class, and this shows that how many outliers are there. This box plot is good in identifying the distribution and also the outliers. So I can see that in class 2 and 3 I've got so many outliers. That means extreme values, and that too the values I can see here that okay, like I can see here that on y-axis I've got age, and on x-axis they're passenger class. So in passenger class 2 and 3 I can see that few people who are aged have bought the tickets of passenger class 2 and 3, right? But they're very few. Okay, and we can see it here, but they have bought it, like that means they are traveling in all the passenger classes, so they are not specific to any passenger class. All right, so this box plot made above observation very clear, which I say stated that here the histogram and the above histogram which I concluded that elderlies are might be traveling in passenger class 1. So that's not true because the box plot says something else. Okay, now I will come here to show you again the Titanic data. Now why am I showing you? Because we are going to drop a column called cabin, which is not needed to carry on our with our data set further. So I've just dropped this column, okay, to make it as good, neat as possible. And when you drop it, and now you want to see that is there any null values present here, because we've dropped the null values also. So we see that there are no null values present here from the age and from the this thing where we had null values in the age column, and also in the cabin it's already been dropped, and embarked, so they have been dropped. Okay, right. So now we come on to, this is simply showing you the is null dot sum, is there any null value. So you can see that there are no null values. Also guys, if you want to see the entire documentation what I'm talking, it is available on the website, so you can just see the entire process here also. I will provide the link in the description box, and also for the other Kaggle competitions which you can really participate. Okay, so now we are coming to the model building process of it. So as you can see that this is a Titanic, this is a data set. Now we've got certain columns here and rows here. So as you can see, these are the columns we'll be working with. And now when you see that we've got embarked, the sex, and the I would say these passenger class columns. Now these columns, these are categorical columns like sex and embark. That means you've got male, female, or you've got various boarding stations here, right? Ports here. So we will convert them into numeric, because the machine learning algorithm only understand numbers, and they do not understand these the language like male and female. So these are categorical data which they do not understand. So we'll be applying and fitting this logical regression, and for this we will convert these categorical data into binary or integers, right? Okay, so for this I have applied one hot encoding, and this one hot encoding does nothing but it helps you to simply convert the values which is having the value as 1, and rest is converted to 0. So as you can see, one hot encoding, so every possible value, it creates one column for every possible values, right? And the if you want to go into detail of one hot encoding, there's a video, I'll provide the link, and you can go ahead with that. So for the convenience sake, just understand that one hot encoding. For this I have simply used the get dummies function here. Okay, and let's see how does this work. So what happens here is that I am first applying this get dummies function, pandas.pd.getDummies, in the Titanic column sex here, and I see the head here. So what happens here, that this column sex, right, each column, the row is being converted into a column. That means male and female has been converted. It has got only two unique values, and respective positions are being filled. Suppose the first passenger, like the first this thing row was a male, so you got one here. Another one, first one was female, so you got female one here. That means he is not a male, he is a female, right? So what another thing get dummies negative point is that we get multiple columns here, and which can be redundant. So what I do is I can drop one female, one this female column or a male column. So what I do is I simply create an object called sex, and in that I say that you get dummies from Titanic dataset from this column sex, and you drop first equals to true. That means the first column would be dropped, so this female would be dropped, and I can easily infer that if this passenger ID, that means this index is 0 and is a male, that means is not a female. The second index, that means he's a male, is not a male, will be a female. So what I got is I just need just one thing to tell me whether the passenger is a male or a female. So I can see here that this is a male, this is a female, this is a female. So what I did was simply to drop one column from it, right? The first one column has been dropped. Okay, now similarly we can do this with embarked. Now there are three stations here, S, C and Q. So there are three unique values. These three unique values have been converted into columns. So we've got here Cheersburg, Queenstown and Southampton, right? So these have been here converted into respective columns, and the data value has been filled, but I have seen only the top three values here. Now what you do is, again, if we drop the first column here, again we can infer with these two columns whether the port was Cheersburg or not. Okay, so if this is Southampton, we understand that okay, the first index location is from boarding from Southampton. The second one is neither of the two, that means it is the third one, C, that is Cheersburg. Okay, Cheerburg. Okay, now similarly here the second one, as you can see, it is S, that means it is Southampton. Alright, so this is how we go with the one-hot encoding, and we have used the get dummies function here. Similarly, we can do it with passenger class. The passenger class has values like 0, 1, 2, 3. I mean 1, 2, 3. So what we do is we again apply this get dummies function to the passenger class, and we drop the first column. So the first column has been dropped, and we can infer from this that the second class and the third class, and we find here that the first value belongs to the third class, first location belongs to first class, because the second and the third values are 0, so naturally it has to be first. So this is how we can infer, and so it was redundant, so I can drop any of the columns. So I dropped the first one, okay, just to make things simpler. Now what we do is we have to concat it. We have to just add all these individually created objects into one data set. So we've created another data set, that is Titanic again, and we have concatenated the Titanic original data set, the sex, embark and the PCL here, and the axis is 1. Okay, axis is 1, that means this is the column which it will go and concatenate these columns. So as we can see, the top three entries, this has been concatenated, and now we see that we have got various columns which are redundant and we do not want it. So we drop those columns also, like sex, because we already have now male here. We have embarked, which we can be dropped because we've got Queenstown and Southampton here. And similarly, we can drop this P class because we've got 2 and 3. So I have dropped these things here. Okay, and also ticket is also not important, so let's drop ticket, name and passenger ID. Okay, from the axis is equals to 1 and in place equals to 2. Axis equals to 1, that means it will go in here above column and it will just remove it. Okay, so when we see this, this is what the data we have, that is only specific, the Quinston, Southampton, the class, that is 2 and 3, fair, Parsh, SIB, SP, you want to drop it, you can drop this also, survived, and age. Okay, now we come to the model building process of it. Now what happens with model building process? I'm just using logistic regression here, and we can use various algorithms if you want, but since it is like prediction problem 0 or 1, 1 or 2, so we can use logistic regression quite boldly. It is robust here. So I create an X. In X, what we do is we do not take this survived column because that is what we have to predict. So in X, we will drop this, and in Y, we will only take this survived column. Okay, so we've created two objects, X and Y. And this train test is split is in sklearn model selection module. So we will go and import it from sklearn, and we will create X train, Y train, X test, Y train, and Y test. Okay, and then train test split object that we have imported, we will give this X and Y, which will be splitted into the train and test data, and the test type would be 0.33, right? That means 70% and one third percent is the test data, rest is the training data. And random state is 4. You can take any random state, it could be 10, 9, any random state. Okay, all right. So now we go on to applying the logistic regression. The algorithm used is logistic regression. So it is in linear model, so you will import it logistic regression, create an object wherein you can store this logistic regression model, and now we will apply this on X train and Y train, right? So this has been applied, as you can see that here, class weight, dual, fit regression, and everything. So this has been applied. Other parameters, if you want, you can pass it by using shift plus tab. Okay, now what we do is we go on making predictions. So we make prediction first of all on X test. Okay, and you go on using the classification report and the confusion matrix. These are the matrices we will use metrize to understand the performance of the algorithm, how good is it, right? So when we have imported this, it is giving me some precision of like 0.7, recall is 90, which is good, and the accuracy is 78%, as you can see here, right? Okay, so on X test, my prediction is 78%. Now I want it on Y test. What I do is, I will simply go on predicting this thing on accuracy score. So accuracy score, I will write here Y test, and on prediction, this prediction is the object which we have created further, and where we have predicted the Y test, and this X test, and this X test, how much it gave me the accuracy of 78%. Now let's see whether it matches the Y test or not. So that's what I'm doing here. In accuracy score, I want to test this Y test and the prediction, and this is giving me somewhat around 79%, which is greater than the 78%, as you can see. So this is what it shows. Okay, so that means this model is giving me something like 79-80% accuracy here, and this is the classification report and the confusion matrix. As you can see that it is making really wrong predictions. You can see 17 have been wrongly predicted, 31 have been wrongly classified by the algorithm. So there are more chances and further scope of improving this result by applying various ensemble algorithms, AdaBoost or XGGB boost. Here we can apply. We can also use SVM or naive bias to get more good predictions, more than 80%, 79.5%, more than it we can get it. So this was just a basic tutorial about how to get started with the Kaggle competition. So you can also, one more thing, that you can go to the notebooks for further clarification if you want, and this will really help you out with various kernels, because various people just post their code and you can go and see their codes. Okay, and even I have my posting here, I suppose. So this is how the Kaggle operates. You have to make your account in this, and see your score, where you score, right? Okay, and go ahead and see this. For the documentation for what I'm saying, it has been written here also, and along with the references you can find it in the website. This In the next video we shall discuss more about machine learning algorithms and the projects. Just let me know on what projects you're working, guys, and keep commenting, and do share, like, and subscribe. Thank you.
Welcome back, and today we shall discuss about regression algorithms in machine learning. So let's start with the introduction of what is regression algorithms. Actually, regression algorithm and classification algorithms, they are used to solve the machine learning, supervised machine learning problems. So classification algorithms are already being done. Refer, I will provide the link and the end screen. In the end screen, you can find that. So we'll be discussing about regression algorithms. So here, regression, as the name suggests, it deals with the continuous data, unlike discrete data, which we have seen in continuous, which we have seen in the classification algorithms. So this continuous data is in the form of range or interval, wherein you have groups. You've got like 0 to 1, 0 to 10, 10 to 20, and so on. This is how you group the continuous data. You don't have a discrete value for that, like 0 or 1, or A or B or C. Like they cannot be grouped into a whole number, a whole digit, or a discrete complete data. So now I walk you through the example to make it more clear that few regression problems are like predicting house prices. And we've done one machine learning project on this, is Boston housing price detection or prediction. And since these prices are in a continuous range, like $10,000 to $20,000, $20,000 to $25,000 slab, so this is coming under the regression problem. The second is weather conditions, wherein you have to predict the weather conditions, and it is not discrete because it again comes in interval, like 33 to 35 degrees Celsius. It is not very certain. We have to predict it. Then another example is stock prices, wherein you have to predict, which is again very uncertain market, and this prediction again goes high or low. And an age group also is also a continuous example or a regression problem. So now moving on to our different types of regression algorithms, and firstly is the linear regression. So I'll walk you through linear regression. This is the most widely studied algorithm since decades, and it has been used in statistics, and now it is being used in machine learning. It is the earliest, or you can say the first regression algorithm that we'll be dealing with. Now this is very simple algorithm, as this tries to fit your data in a form of a linear function, in a form of a linear model. So what it does, it is the model assumes a linear relationship between the output and an input variable. And so I say that that is why it is linear, because it is trying to fit the model or the data into a linear function. And it has its many limitations also, because it is trying to fit the data into linear model or linear function, which might not necessarily be a good fit. So it might lead to a poor fit also if it is not a linear model. So now I'll walk you through the figure of this linear regression to understand it better. So you can see that this tries to fit a line, and the data points which we can see in blue dots or blue circles are the points, and this line is a line from where the variance or the error is minimum. So we can see the relationship between the independent variables on x-axis and dependent on y-axis, and the linear relationship is being mapped with this line of regression. A few examples for this could be relationship between weight and height of a person, and how they are interlinked, and what is the correlation. Is it moving in the upward direction or in the downward direction? So once we build the model, we will understand linear regression in greater detail. Let's move on to different type. Another type is L1 regularization. This is also known as the lasso regression. which means it is least absolute shrinkage and selection regularization operator. So it's got a long name. Just to cut it short, we are using lasso regression or L1 regularization in technical terms. So what happens here is it is just a variation of linear regression, and this is used when the data is highly correlated. So I'll just walk you through the diagram and what it really is. See, you can see these lines. There are various data points, there are various variants in the data, and they are being merged into towards a central point. So what lasso does, it is a process where in the data values they are shrunk towards a central point, and it automatically this helps to eliminate or wrap highly correlated and redundant features in a low variance method. So this is trying to reduce the variance of a large amount of data. But I would also tell you that L1 regularization works well when you have got a small data set. Now we shall see further about this in when we do the practical exercise of lasso, ridge, and more regularization techniques. Now let's move on to our L2 regularization, which is also known as the ridge regression. This is similar to the lasso regression, but the difference is that the ridge coefficient, they are never zero, rather they are minimized. So now I'm talking about coefficient and slope and everything because they use this line of equation of line, which is y equals to ax plus c, with various variations in the values, I would say, in the parameters. So they are using this coefficient here. Ridge, the coefficients are never zero. So what happens here is that the ridge regression, it decreases the complexity of a model, but it does not reduce the number of variables. So this is the difference, and this is what ridge regression does. It is again a regularization technique, and we can use it for regression algorithms. So now let's work on to different regularization or regression algorithm, and that is called elastic net. Now this elastic net is a well combination, I would say, of L1 and L2 regularization. This takes the best from both ridge and lasso regression. So this would be more clear when we do the practical exercise of it, that how is it really best and how it is taking the best from both the regressions and how does it really fit the data, what it is really doing. So as of now, just an intuitive knowledge about these regression algorithms. There are many other advanced regression algorithms like locally estimated scatter plot smoothing, it is multivariate adaptive regression, splines, that is Mars, stepwise regression, and OLSR, that is ordinary least square regression. So this is beyond the scope of this video as of now because we are restricting ourselves to basic regularization and regression algorithms here. So I would just end this video here.
Hello friends, and today we'll be doing the data analysis of Boston dataset. So open your Jupyter notebook, launch it, and go to data analysis, the folder you have created for your various data. And for this, we go to new Python 3 and we create Boston dataset, Boston analysis. So what is this Boston? This is a housing price data, and it is a regression problem, and we'll understand more once we start doing it. So what I do is import basic libraries. You start by importing basic libraries and hit here, press 2, shift enter. This is heading 2. Okay, spelling right. So what I do is I import pandas as pd. This is for CSV files for your data processing. Import numpy as np. This is for linear algebra, and I will import two plotting library, that is matplotlib.pyplot as plt, and I'll import cburn as sns. Hit shift and enter to run this code. Now what is, from where do I get this data set? I'll get it from sklearn, from sklearn.datasets, I will import load Boston. Okay, this is how you write. Sklearn, LE. So that has been loaded. Now what I do is, in a Boston object I create, you can name it anything, I will load this Boston. I load this Boston on the Boston dataset. Now let's see how this Boston looks like. Okay, we've got data here, we've got target here, a huge array, a lot of numbers. Okay, we've got feature name here, we've got description here, and you can see the number of instances 506, number of attributes 13. They are numeric or categorical predictive. Okay, what else is there? Fine. So let's just derive each value here. Now if you want to see Boston dot, write on Boston dot keys, and what will happen is it will give me a dictionary of keys, and that's what we've explored: data, target, feature names, description, file name. Now if you want to see individually Boston dot data, see Boston dot data, it will give you the same thing, an array of so many numbers which we don't understand. And also let's see Boston dot target, and it will give me again an array of so many numbers. Okay, now let's just explore further, and we see Boston dot feature names. What is this feature names? Let's see. This is something called this, and there are 13. Okay, then what we'll do is let's just print Boston dot describe and see how it looks. So this is a Boston house prices dataset, and you've got number of instances 506, and you've got attribute 13, and we see that the data is not arranged, so we have to arrange these rows and into column format. That's what we are going to do next. Just understand what are the attributes mean. This is crime rate by town. This is residential land zone for lots over 25,000 square feet. Okay, this is the non-retail business acres per town. Chaz is the Charles River dummy variable, and it is being converted 1 if the river flows through it, and 0 if it doesn't. And this is NOx, this is nitric oxide concentration, how much polluted that region is. And this is rooms, average number of rooms per dwelling. What is the age of the owner who occupied this building prior to 1940. Okay, then this is the distance to 5 Boston employment centers. Similarly, taxes there, parent teacher ratio, how many parent teacher ratio, how, and black population, and further 2 more. So these attributes will determine the pricing of the data, pricing of my Boston houses. So how each attribute influences it, let's see. So I click here so that it goes. Then what I do is I convert the data into pandas data frame to make it more representable, right? What I do is, in an object I just write pd dot data frame, and in that I want Boston dot data, and columns is equals to Boston dot feature names. Okay, and let's just see, this df dot head will give me the above 5 entries, and see it has been arranged into a table format. So these are the columns and these are the rows. Now if you want to see the last entries, just write df.tail, and by default it will give you the 5 values. Suppose if you want to check 10, so in this just write 10 and you get the last 10 entries. Okay, tail is last 10 entries. Check the shape of the data. df.shape. Okay, it's just so it's 506 rows and 13 columns. Okay, so you see that target is not included here. Now what you do is you include the target here. So in the df I will name it as target, and in that I will include boston.target, which we have. Okay, and now you just again check it, df.head, upper 5 values, and see the target has been included in it. So now we can proceed on to further exploration of the data. Let's check the shape of the data. df.shape, see 14. Okay, 506 rows and 14 columns. You can check the data types. Okay, so check the data types, and here you will just write df.d types. Okay, df.d types. So you see all data is in float. Okay, so we've got numbers here, no problem. Let's check whether it is having anything to do with null values. Dot null dot sum, and we see that there are no null values. See, no null values. What happens if there is null value? Suppose if there are like 2 or 3 here, so we have to replace that null value, because if we'll continue with that, we will likely to get an error and our algorithm will not accept this data. So we see that there's no null value, which is good. That means we don't have to fill these values. Okay, next we go to df.describe, and in this describe I will see, okay, let's do dot t. I have just transposed it, and you can use it without transpose. See, without transpose, that means transpose is rows are converted into columns. So I've converted these columns into rows. So just see crime, the count for all this is 506, and you can see mean, standard deviation, minimum, maximum values, and the percentiles. This is what it tells me. Okay, some statistics involved here. Next, let's go to finding the correlation. Okay, now we go to correlation of the data. Correlation between variables or features and the target. I will press 2 here for the heading. So what I do is I will plot it dot figure, and how do I write this? How would I set the size of it? I will set it as fig size and equals, this could be like 12,6, and from SNS I will take this heat map and df.corr correlation. It will tell me of df, and I will also set the annote as true. This annote will give me the values within the blocks. So this plotting, okay, we got our heat map. So you can see here that this is a matrix which we got for correlation, and the values is inside. So with the target, the crime has negative correlation, but it is also highly correlated. The positive correlation is of ZN, Chaz, RM, rooms per dwelling, distance, DIS, okay, and B, black population. And the negative correlation are the tax, L stat we can see, RAD, this is the radial distance from the highways. Age, NOx, pollution, and index. Okay, so you can see the negative and positive correlation. Also, you can see the relation among the variables. Suppose the age and the dis, they are highly related, although negatively, but they are related. Okay, this is the age of the owners, and this is DIS is your distribution. DIS was, if I'm not wrong, this is DIS was distance to 5 Boston employment centers. Okay, so you can just always come and check what was the variables. Now let's come to finding out different things now. Okay, and let's go on to unimodal data visualization, and that means we are going to plot histograms. So I will go to histograms and I will plot them for the histograms for the entire thing. So let's check out. So what I do is I write df.hist. So PLT has matplotlib has this utility of histogram. So I set the figure size is as equals 12,12, and let's see. Okay, so if you don't want this, just put a comma. Oh, sorry, put a semicolon, and this would be gone. So we find this histogram, and we see that the shape. This tells me the shape of the distribution, and we see that the owners are, in. We can see the distribution of age, like it is greater than 50 when you can really own a house. And this percentage of black, you can see black population, it's greater. Few are here, and so graph is not bell curved. We see bell curved here, room per dwelling, and it just goes on increasing and then decreases to greater than 8 and 9. Similarly, you can find of different this population, this pollution of nitrous oxide, the tax distribution. So this lab is absent here, and what else? The crime. Okay, and now we have to also, this will also help us to understand that how these variables really affect the target, how crime affects our target. If crime rate is high, whether people will buy dwellings, buy the houses at that price, and if yes, the prices would be low. And we see the target, that is the pricing, is segregated in this bracket, like greater than 10 and less than 30. Okay, fine, we get a rough idea of it. Now let's move on to plotting the box and whisker plot. Okay, whiskers plot. Now this plot helps me to identify the outliers. So this helps me in identifying the outliers. Outliers are the extreme values, either positive or negative. So again, I will use df.plot, and the kind I want is box, and this is come into brackets. I will want subplots as true, and I want the layout as 4,4. It will be arranged like that, and I want the font size as 8, and let's set the fig size. The figure size would be, it has to be equals to 12,12. Okay, and I'm sorry, I have to just erase this also. So you can see this, the box plot. Okay, so the crime rate has so many outliers, and ZN. Even the black population has so many outliers. Parent-teacher ratio has outliers. RM, room per dwelling, has outliers. This age has a long whisker. So we find that these outliers will affect my model performance, and these have to be removed, or they have to be balanced in a certain way before training my model. I can also show you if you want to just plot single plots. So what you do is SNS dot distribution plot, and I want to do the distribution plot of what, of the target, let's say. Okay, target, what I get is this. So you can see here that it is maximum pricing is like from the average, if I can say, is from greater than 10 to line between 30, and maximum goes on to like 50. Okay, next, if I want to see another feature, if I'll show you, is of join plot. And here I give an X. I will give suppose I want to see room per dwelling and how is it related to target, and I give it Y is equals to target, and I will give that from where it will take it from data.df, and the kind would be suppose I want that hexagon, and let's set the color also, and the color will be green. Okay, so it is giving me the joint plot. So you can see the histogram here and the scatter plot here. So it is a combination of scatter and histogram, and I see rooms per dwelling. The maximum, or you can say the average, rooms are between like 4 to 6, and the pricing is also concentrated here, as you can see it here, and the maximum rooms goes to 9, which means the higher the rooms, higher the number of rooms, higher the prices. And mostly people are limiting themselves to 5 to around 7 or 6 rooms. Okay, manageable. So this was joint plot, and you can just go on with more plots if you wish. You go on with experimenting with different targets. You can just go here, C, B, and see how does it look. This means that the percentage of black population, so you can see here, is it affecting any housing prices, and we see that no, it does not affect. And the concentration of black is like same. Okay, here 20, 30, and people are not affected by this. You can change this again, this variable, to tax if you want. I think this is, yeah. So let's see. Tax is not there, fine, so let's take this tax. Okay, we don't have tax here, so crime. Okay, so just we can analyze it by crime also, that higher the crime, lower the prices, and no crime, higher the prices, right? Okay, so this goes with our data analysis, visualization, exploration of Boston dataset, house prices dataset. And to check out for the entire code, please visit the GitHub link for the entire code, training and testing of data, and stay tuned for more interesting projects. Thank you.